Good afternoon. As part of our ongoing briefings prior to launch of Discovery on STS Mission 114, we have another briefing this afternoon. It is a shuttle processing overview. And we have with us today John Cowart, who is the manager of the JSC resident office here at the Kennedy Space Center. He'll have a presentation, and then we'll go to some questions after that. John?
Bruce, thank you very much. Good afternoon, everybody. What I want to talk to you about today, of course, is shuttle processing. Generically, how do we get all shuttles ready to go fly? It's a very lengthy process and pretty detailed, but I'm going to keep it at a pretty high level for everybody. First of all, welcome. You all know where you are. You're in the land of the right stuff. This is where we've always launched humans from space, and we'll continue to do it hopefully for a long time. Now, for those of you from out of town, I always like to start with my "You Are Here" slide. For those of you from way out of town, this is where you are. You're located on Merritt Island, which is a barrier island that varies in width from 5 to 10 miles, about 34 miles long. But we have about 160,000 acres here on the Space Center. We only use, though, about 6,000 of those acres for processing the site hardware. So the land that we're not using, we've turned over to the U.S. Fish and Wildlife Service, and they've established the Merritt Island National Wildlife Refuge and Cape Canaveral National Seashore. One of the things we're very proud of around here is that we do indeed do all of this very high-tech stuff in the middle of a wildlife refuge, so we're very proud of that. Now, right across the river from here at Kennedy Space Center, we have the Cape Canaveral Air Force Station, where we launch a lot of unmanned rockets. And you see, for example, there's an Atlas, followed by a Delta, and a Titan. But of course, our primary concern is going to be the Space Shuttle. Let me give you a quick tour around the Space Shuttle right quick. Very often people refer to the winged thing right there as the shuttle. Those of us in the business refer to that as the orbiter. To us, the shuttle is all of these pieces combined. You have the two solid rocket boosters flanking that large orange external tank, and then sitting on the outside of the external tank, just attached to it, is of course the winged orbiter. We have the orbiters in our fleet are Discovery, Atlantis, and Endeavor. And what amazes me, when this whole thing lifts off, it'll weigh somewhere in the neighborhood of about 4.5 million pounds. But we develop 7 million pounds of thrust, which is why we go up at T0. In about 8.5 minutes, we go from a standing start to about 100 miles in altitude, about 1,000 miles downrange, and moving about 5 miles per second. So it's an amazing thing to watch for those of you who've not seen it before. Here is where every processing mission starts for those of us here at Kennedy Space Center. This is the shuttle landing facility. Also, it has a kind of a more common name among some of us in the processing group. It's also known as the Gator Canning Facility, because what you have here is a 100-yard wide, 3-mile-long strip of concrete that is a wonderful place if you're a reptile to come and sun yourself and get nice and warm before you go out for the day's hunt. So we have people who are trained to go out on the runway right before the orbiter comes into land and get any gators that are sunning themselves off of the runway before we do land. As I said, this is where the missions start. We either land from space or we come on the back of the 747. And we've done some modifications to the orbiter, improved the brakes down here. We've added the drag chute, so Kennedy Space Center has become the primary landing site. We either come from space, I said, or we come on the back of the 747. If we're on the back of the 747, we have to get it off. Now, the way we do that is we take it over to our 11-story high mate-demate device. We pick the orbiter up off the back of the 747, push the 747 out of the way, lower the orbiter down to the ground, and then deploy its landing gear, and then we tow it to one of our 3 orbiter processing facilities, or OPFs, as we call them around here. Here you see the orbiter about to go into one of those orbiter processing facilities, or OPF bays. These are really nothing more than sophisticated aircraft hangars. I'll give you a picture inside one here in a minute. Let me show you just around the outside of the orbiter right quick and give you a couple of things. First of all, here's the nose, or the forward area. This is the crew module. It's where the astronauts are during launch and re-entry. Behind that, for 60 feet, is the payload bay. And then behind that is the aft of the engine compartment, which houses all the plumbing you need for the 3 main engines. Each one of those main engines develops about 375,000 pounds of thrust here on the ground. But also, here in the back and up around the front, there are 44 smaller jets known as Orbital Maneuvering System Reaction Control System jets. Now, what these allow you to do is to point and steer and do altitude adjustment capability once we're up in space. The big 3 main engines shut down after 8.5 minutes, and they're not used again. Those 44 smaller jets and then the 2 OMS RCS, or the OMS engines I was telling you about. Here's where I hope to convince you I'm a rocket scientist. We use monomethyl hydrazine and nitrogen tetroxide, which are hypergolic chemicals. In other words, they really, really hate each other. When they touch, they explode. I don't need fancy spark ignition devices. They're not cryogenically stored. Very, very simple to use. Open the 2 valves, boom, rocket propulsion. Extremely simple. The downside is they're very toxic. Whenever you see people working with these chemicals, they're essentially wearing a spacesuit on them so that they don't breathe any of it or get any of it on them. Because if you do, you're going to go to the hospital because you could get very, very sick, or if you had a bad enough exposure, you could die from these chemicals. But as I said, we trade off the ease of use on orbit for that hazardous use down here on the ground. Here's what it looks like inside the orbiter processing facility, and yes, there is an orbiter inside this picture. What this allows you to do is access every square inch of the vehicle, from inside the wheel wells to the top of the vertical stabilizer, everywhere the engineers, technicians, inspectors, all those folks have to get to do all that work on the orbiter. Now, if you look very carefully, right here, you'll see the nose of the orbiter, and then the windows for the crew module would be right there, and then extending back in that direction would be the payload bay. So that's what it looks like inside the OPF. Here is the most labor-intensive thing that we do on the orbit. It's the tile. Now, originally we had about 30,900 unique individual tile on each orbiter. We've reduced that number to only 25,000 through the use of heat-resistant blankets in some of the cooler areas, like along the top of the wings or the sides of the payload bay. These tile here on the bottom have to dissipate or can withstand about 2,000 degrees of heat. Now, the leading edges of the wings and the nose cap of the orbiter are made of another material called reinforced carbon-carbon. Those can take about 3,000 degrees. What happens during reentry is you set up a shock wave right in front of the orbiter, and that shock wave, the temperature that actually touches those tiles is somewhere in the neighborhood of about 2,000 degrees. Now, the skin of the orbiter is made of a very unexotic aluminum. It will begin to stretch and anneal around 350 degrees, which is why those 2 to 4 inch thick tile have to dissipate somewhere in the neighborhood of perhaps 1,700 degrees before that heat gets to the skin of the orbiter. Very, very effective at what they do, but each tile takes a long time to apply. They're very, very high-tech things. Here's where you want to get to if you're an astronaut, or even if you're me and you want to be an astronaut. This is the flight deck. Commander will be sitting here, pilot will sit there, and then 2 mission specialists will sit behind them up at the flight deck. Now, downstairs is the mid-deck area in the crew module where you can put 4 more astronauts if you need to. What you see right here are the CRTs for the 5 computers that we have on board the orbiter. Now, these 5 computers are running all the time, checking each other, seeing if they all get the same answer. If any one computer gets a different answer than the other 4 go to tribal council, and that one is voted off the island. What really happens is, yes, if one gets a different answer, he's turned off. It's not an emergency, but it is something we watch, because if you lose another computer, then our flight rules dictate that you should probably be coming home sometime soon. The computers that we use on board the orbiter are 80s vintage technology. Now, for those of you who think, why don't you update it? The reason being, it takes millions of dollars and years in order to certify computer hardware and software for use in human spaceflight. It's one of the quickest ways to cause a problem in a mission. If you look at the expendable launch vehicle failures that have occurred over the last 10 years, I think you'd find about half of them are caused by computer hardware or software problems. So we're very, very careful. We've only got 5 years left in this program. We know how these computers work. We understand all their idiosyncrasies. We're going to stick with them. We're going to fly with them. And for those of you who might suggest, well, perhaps Bill Gates could do it faster, better, cheaper, with all due respect to Bill and Microsoft and everything that they have done for the computer industry in this country, at 17,500 miles an hour and with a pure vacuum right outside your door, Control Alternate Delete is not one of our options. Our computers absolutely, positively have to work all the time, no exceptions. So that's the flight deck. Here you see the payload bay. Now, every payload we fly has completely different electrical, mechanical, fluid, and data connections. So after every mission, we strip everything out of the payload bay, put the new stuff in, and we're ready to go fly the new payload. Here you see a space lab with a tunnel coming back, and there you see the orbiter docking system. And there the astronauts would go back in there once we're up in space, and they would start doing their experiments. The most high-tech part of the shuttle, the main engines. After every mission, we take out all 3 of the main engines, send them to a special lab we have where we examine them, inspect them, and do any repairs that are necessary based on what we find or anything that's just timed out that's been on there long enough. These engines are really, as I said, the most high-tech part of the whole space shuttle. Let me tell you a couple things that really impresses me about them. First of all, they operate at the extremes of temperature. The fuel we use is liquid hydrogen. At minus 423 degrees Fahrenheit, that is the second coldest liquid in the universe. When you combine that with liquid oxygen right there in the combustion chamber in the throat, the temperature there can exceed 6,000 degrees Fahrenheit. That's hotter than the boiling point. Not the melting point, but the boiling point of iron. Iron would be a gas at that temperature. So the obvious question is, well, then why doesn't the engine bell melt under that extreme temperature? The bell itself is made of hundreds of tubes welded together. And before the liquid hydrogen is sent into the combustion chamber, we flow it through those tubes and we cool the engine bell down. The other thing that's amazing, and most of you have probably heard this one before, but you look, there's a thing over here about the size of a beer keg called a high-pressure oxidizer turbo pump or a high-pressure fuel turbo pump. We have both of them. If you were to take those pumps and pump water instead of hydrogen and oxygen, you could drain an average-sized swimming pool every 25 seconds when we're going up the hill. Now, we're ready to build up the stack. We're getting the orbiter ready. We've got to have a stack ready for the orbiter to get onto. Here's what we're going to build it on top of. Here you see the crawler transporter, and on top of that, this big battleship gray thing is the mobile launch platform. Here's a crawler transporter without a mobile launch platform sitting on top of it. You see each one of these treads here is composed of about 52 individual cleats on each one of those. And you see we have those in all four corners. Each one of the individual cleats there weighs 1 ton by itself. Now, the crawler transporter has a top-loaded cruising speed of 1 mile per hour, and it sits the diesel fuel at just 150 gallons per mile. Here's where we're going to do the stack buildup. We take the mobile launch platform and the crawler inside the vehicle assembly building. It's the thing which dominates the landscape out here. 525 feet tall. There you see the Launch Control Center down beside it. Here you see us beginning to do the buildup of the solid rocket boosters. Now, what you may not know is that each solid rocket booster is made of 4 solid rocket motor segments, and we stack them one on top of the other. Here you see 2 aft segments that have been put down. Here is an aft center segment being put, and then another one will be put over here. Now, we can stack, left, 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 right, right, right. It doesn't matter if left, right, left, right. It'll work either way. But there you see us beginning to do the stack of the solid rocket boosters. Once the boosters are completely stacked up, we're ready for the external tank. Here you see it right here. Big, beautiful thing comes to us from the Michoud Assembly Facility out in Louisiana. Overall, it's about 154 feet long, 27.5 feet in diameter. When it's empty, it weighs around 55,000 pounds. When it's full of over 500,000 gallons of hydrogen and oxygen, it weighs 1.5 million pounds. It takes all of the thrust loads of the shuttle through these attach points you see right there. So it is really an amazing thing. There you see the external tank in the vehicle assembly building. We take it from horizontal to vertical, lift it up high, and then we join it in between the 2 solid rocket boosters in 4 locations with explosive bolts. Okay, now we're ready for the orbiter. We go over to the orbiter processing facility, whether it's Bay 1, 2, or 3. In the case of Discovery this time, it was over in Bay 3 most of the time. Bring it over on top of this transporter. Hook up our cranes in the vehicle assembly building, which will once again take it from horizontal to vertical. You disconnect part of this crane or part of this lifting fixture right here, and then a single crane will take it up and over and gently lower it down and attach it to the external tank in 3 locations with explosive bolts. We'll spend about a week inside the vehicle assembly building testing all of our interfaces and making sure it's ready to go before we roll out to the launch pad. There you see it. There you see the crawlerway heading out to Pad B or Pad A, and then over here would be Pad B. If you're in the crawler transporter and you're going out there to Pad A and you've got that thing floored, it'll only take you about 6 hours to get out to the pad, to go 3.5 miles. If you want to go the full 4.25 miles out to Pad B, that's about an 8-hour full shift for you to get there with the whole stack on your back. Here you see what it looks like inside the Launch Control Center. Once again, older computer technology you see right here. Once again, we're going to save money. We're not going to upgrade our computers. These things work. We understand all their idiosyncrasies. It's the same story as it is with the computers on board the orbiter. But that's what it looks like inside the firing room. The only downside to being in the firing room is if you go off the wrong pad, you can't see the shuttle lift off because the building just doesn't face in the right direction. A lot of people think it would be exciting, and it is to a certain extent to be inside the firing room, but it is a fairly antiseptic experience because you can't really hear it or see it or feel it like you can when you're standing outside. So those of us in the firing room, after about 10 seconds into the flight, are really very jealous of those of you who are standing outside watching it lift off. Here you see the whole shuttle stack on its way out to the pad. When it gets to the pad, it has to navigate a 5% grade in order to get up to the pad surface. So what happens is the back of the crawler will actually jack up by as much as 6 feet in order to keep the whole stack level while it's going up that hill. There you see it at the top of the pad. There's the white room. This is where you want to get to if you're an astronaut. That's your last stop on Earth. Everything gets connected. We sit at the pad for usually about 4 to 6 weeks. About 2 weeks prior to launch, we usually bring the crew out. We do a countdown demonstration test where we take the crew and we suit them up in their orange suits, act just like we will on launch day, send them out there. They go get strapped in, do a lot of simulation. The biggest difference, of course, being usually the rotating service structure is still around the vehicle, and there's hundreds of people working around the vehicle, which on launch day there will only be those astronauts and maybe 5 to 7 other people out there on the pad. So a very different experience, but we do get them used to what it's going to be like. Here you see that rotating service structure that I talked about. What this thing does, we actually put the payload inside this thing called the Payload Changeout room. Now what happens is, usually before the whole shuttle stack gets out to the launch pad, we bring the payload out to the pad, we lift it up until it's touching these Payload Changeout room doors, or the PCR doors as we call them. Those doors will open up. The canister that we have the payload in, its doors will open up. Then this thing called the Payload Ground Handling Mechanism, or the PIGM for short, will reach out into the canister, grab the payload, pull it inside the Payload Changeout room. We close the doors to the Payload Changeout room. We close the doors to the orbiter. We lower the canister down to the ground. Then we take the rotating service structure and we bring it all the way in and around the vehicle in order to provide access for the engineers, technicians, inspectors, and to provide protection from wind and rain and even digested seagull food. And then we take and open up the doors on the orbiter, and we insert the payload into the orbiter itself, close the payload bay doors in the orbiter, and then the payload is essentially ready to go fly. So there you see us at the pad now. We have a payload inside there. It's ready to go fly. Usually about 10 hours prior to launch, we begin filling the external tank with 500,000 gallons of hydrogen and oxygen. That process will take about 3.5 hours, which is a long time when you consider those little pumps I was telling you about will drain the tank in 8.5 minutes. So we begin the process of filling it. It's a very slow, methodic process. When that's done, we send a team out to do an ice inspection, verify that no ice is formed in any bad areas. Then somebody gets to go wake up the crew if they're even sleeping. Not exactly sure what they would be concerned about. Then the crew has their breakfast, put on their orange pumpkin suits, they drive out to the launch pad, and then one by one, they crawl up inside. There you see them doing their walkout, doing their wave, and there's Eileen coincidentally. Then they get inside the crew module, get their helmets on, do their comm checks, verify everything's ready to go, and that's Senator Glenn in the middle right there. Once that's done, we close the hatch on the crew module, verify the crew module isn't leaking, we kind of bump up the pressure inside. Crew always appreciates that. And then I like to say that all the really, really smart people in NASA get 3.5 miles away, leaving these 7 individuals with about an hour to an hour and a half to contemplate the career decisions they've made, which has led them to be sitting on the explosive equivalent of a small nuclear weapon. There's really not a whole lot for them to go do. We only have 6 or so call-outs for the crew to go do stuff for us from down on the ground. Other than that, I'm sure the commander tries to keep it as light as he can inside the crew module. But we continue on with the countdown until finally, T-minus 6.6 seconds. We kind of stagger each one of the main engines on the back of the order. We stagger start them. Now, it only takes 3 seconds for them to come up to full power. And so the obvious question would be, well, then why do you start them at T-minus 6.6 seconds? Well, you have to bear with me here for a second and imagine that I'm an external tank with an orbiter just hanging off my chest and the 2 solid rocket boosters on my side. What's going to happen is when those engines on the orbiter, as I said, the orbiter is not supported from the ground anyway. It's just hanging on the external tank. When the engines on the orbiter build up their thrust, they will actually bend the external tank by as much as 3 feet up at the top. Now this whole process was identified for us by the folks at the Marshall Space Flight Center in Huntsville, Alabama. So they came up with a very technical term for it. And the term is called that bending, and then coming back to pure vertical is called the twang. So what you do is you get bent. Once there's enough stored energy, it'll twang back to pure vertical. How long do you think that takes? 6.6 seconds. That's why we do. We don't want to be launching when we're all bent over like this. We want to be going straight up. So at T-minus 3 seconds, the computers start checking about 100 times a second. Are you at full power? Are you at full power? If any one of those answers with any of those 3 engines comes back no, we have an abort there on the pad. But if those all stay good, finally at T0, we are so confident that the solid rocket boosters are going to ignite. We send the command that blows the bolt, holding the vehicle to the ground first, then we send the command that ignites the boosters. Granted, it comes less than 1,000th of a second later, but nevertheless, gives you some idea of our confidence. And when that happens, each one of those boosters goes from 0 to about 3 million pounds of thrust in less than half a second. And if you're up on the flight deck and you happen to be napping, this is probably going to wake you up. There you see it, just as the boosters have ignited. Now also down on the pad at this time, you will have seen about 300,000 gallons of water begin to flow in 30 seconds down onto the pad. The reason being, when the engines ignite, the noise is so loud, it was going down, hitting the bottom of the pad, and the echo coming back up would knock tile off of the orbiter. So as I said, at T-minus 15 seconds, we begin flowing about 300,000 gallons of water below the pad and then onto the pad surface and to help deaden that noise so we don't get any of that echo coming back and knocking tile off. Here's a fairly critical point. When the engines get to about this point, we turn over control from Kennedy Space Center to Johnson Space Center in Houston, Texas. Now, for those of you who may not have seen it before, I have a real quick 30-second clip of what it looks like inside the crew module when you go for engine start in that initial ascent. If y'all could roll that for me right quick.
Autoing.
There we go.
100.
There you go.
2 and auto. 104. 8-second roll and roll program, Houston. I see it. Roger, roll discovery. On the right. On the right. All right, things are looking good.
There you go. Now what's really cool is we follow that all the way to the end of the 8.5 minutes. You kind of, just as the main engine shut down, you do kind of see them lurch forward just slightly. But the real cool thing is then one of the crewmen holds up a pin and lets go of it. It just floats there. So in 8.5 minutes, you've gone from being down here in this gravity well to being up in 0G. Here you see the vehicle at about 20,000 feet. It is rotated to a heads-down configuration. The vehicle is more stable that way, and it also gives the crew better reference if they have to do an abort. About 2 minutes and 6 seconds into flight, the solid rocket boosters are jettisoned because they're about done. They continue on in a giant arc. Finally, about 150 miles out in the ocean, a small drogue chute will first deploy, then 3 larger chutes will deploy and lower them down into the ocean. There you see the drogue chute. Once again, to give you a sense of scale, you see that one drogue chute, then it's going to deploy the 3 mains. Each one of the main parachutes on each of the boosters weighs 1 ton by itself. 1 ton seems to be the nice round number we have in this program for a lot of things that we do. But there you see, then one of the ships, once it splashes down, one of the ships in our NASA Navy will go out there, retrieve them, take them from what we call bobbing up and down to what we call log mode, bring them back to the Cape Canaveral Air Force Station across the river from us here. They will take them apart, clean them, inspect them, ship them back to Utah. Our friends with Thiokol will refill them with solid propellant. They'll ship them back to us, and we will reuse the solid rocket boosters. Now, you may remember we last left our 7-0 still going upstairs when the boosters separated. Well, here you see at the end of that 8.5 minutes. The tank is essentially empty. It is jettisoned. The tank will then float away, as you see it does right there. It doesn't have quite enough speed to stay in orbit. So usually somewhere over the Indian Ocean or the South Pacific, it will re-enter and most of it will burn up. The orbiter, on the other hand, about 30 minutes into the mission, will fire its orbital maneuvering system engine. You remember those special hypergolic engines that I spoke of? It will fire those again, or for the first time, in order to give it that tiny little extra burst of speed that it needs to stay up in orbit, whereas the external tank will re-enter. Then the first thing they do once on orbit is open up the payload bay doors. Those are giant freon-filled radiators. We have hundreds of electronics boxes. 7 heavy-breathing astronauts just been through the ride of their lives, and we need to cool them down, and that's what the radiators do for us. Then they get to start doing all that really cool astronaut stuff that they do on orbit, and I'll leave most of that to my friends over at the Johnson Space Center in Houston, Texas. They're the ones who are responsible for all that on-orbit stuff. Get to do a lot of cool things. We can deploy satellites. One of the neatest ways to do it is to take the robot arm. You can capture a satellite like the Hubble, or you can deploy a satellite. Robot arm, what it would do is just be to grab the payload, whatever it is, hold it up above the shuttle, release it, and then the orbiter just backs away, leaving it in whatever orbit it was in. This is probably the most fun. I'd call this getting to go outside and play. You put on your own personal spaceship, and you go outside, and right there, 250 miles below you, is your home planet going by at 5 miles per second. I can't imagine anything that would be more exciting than being able to do that. One of the interesting things on the International Space Station, the way the airlock is arranged, when you open up the hatch to the airlock, it faces straight down. So one of the astronauts, the first one out, when he opens it up, all he can see is the Earth below him. So if you have a fear of heights, you're not invited to apply to be an astronaut, I can assure you. Here's, of course, what dominates the manifest for the rest of the shuttle's life. Now, usually somewhere over the Indian Ocean, Australia, basically on the other side of the Earth, we turn the orbiter around, fire those orbital maneuvering system engines again for the last time. They will not be used again to slow us down just enough so that we begin the reentry process. Usually somewhere west of California, they begin to feel the effects of the Earth's gravity, and not the gravity, but the heating that comes from the entry interface at around 400,000 feet. And then they come into Kennedy Space Center. They land on their mark every single time, not just because they're great pilots to start with, but because we also train them in a special aircraft we have that simulates how the shuttle flies or how the orbiter flies. They roll out, and we start that process all over again. In a normal year, normal mission processing times, it takes us somewhere in the neighborhood of about 6 months to get the orbiter and the whole shuttle stack ready to go fly. And there you have it. That's how we get shuttles ready to fly here at Kennedy Space Center. So, Bruce, I'll give it back to you.
All right, thanks. Well, we're going to open it up for some questions. John makes it over here and takes a seat. So we've got a microphone. Wait for the mic, please. Give us your name and affiliation. And so any questions? Okay. Mike, right here.
Hi, Mike Schneider, Associated Press. I was wondering, given that you had done this in more than 2 years, the whole process thing, was there any element of being a little rusty in any, say, lost information, or was it pretty much as easy as if you had been doing this 4 or 5 times a year in the past 2 years?
I wouldn't say that there was any lost information. I wouldn't say there's any lost information. I would say that, yeah, anytime you've waited 2.5 years to go do something you used to do 3 or 4 times a year, there's going to be some element of, let's see, now, did I do it this way? Our procedures try to take that into account, and the way we process the procedures are very, very detailed. Of course, you do have some experience factor, as you would in any job. So I would say that no, we weren't too rusty. There were probably a couple of occasions where we consulted with each other and said, is this the way we did it before? But we took the time and did it right.
All right, that's good. Wait for the microphone, please. All right.
Randy Avera, Randolph Publishing. John, as we look around Kennedy Space Center today, we see the VAB vehicle assembly building with repairs from hurricane damage. Do you know of, or could you elaborate or tell us anything you may know of about NASA's plans to improve the facilities here on Merritt Island and right out on the launch pads at Kennedy Space Center for not only the remainder of the shuttle program, but also the future possibilities of commercial space operations here at the Kennedy Space Center?
Well, see, I can address the shuttle piece of it. I don't know what would happen over on the expendable launch side. But as far as with us on the shuttle, I know we have a lot of money dedicated every year to maintenance of our facilities. There are a few upgrades we're doing, trying to make sure that we stay as current as we can, but we have to keep an eye on the fact that, yes, this program is going to come to an end. We want to be wise stewards of the taxpayers' money, so we don't want to do anything we don't have to do in order to get this program to the end of its mission. Now, with that said, we know there's going to be a follow-on mission. We're not going to let anything just dwell to the point where we know on the launch day of the last mission, that is the end of life of that piece of hardware. We want to make sure that we are well set to proceed on into the next program, however that wants to be done. There are a lot of ideas about how you could do that, whether you use a shuttle-derived vehicle or you just use expendables. We're not 100% certain what we're going to go do. So what we're trying to do is make sure we are positioned with good facilities, even at the end of the program. We have to be just as safe on the last mission as we are on the first. Make sure we're positioned in order to stay current and go on with whatever the next program might be.
So are you saying that you're not aware if NASA has a dedicated program to address the hardening of the critical facilities for future space vehicle processing?
I'm not involved at that level, Randy, so I got to say I don't know for sure. But as I said, I know we are making sure we're good for the remainder of this program and the start of the next one.
Okay. Any other questions? All right, stick it over there by the door, please.
Richard Sisk, New York Daily News. Has anything changed since Columbia in this drill you just went through about typical shuttle launch? And if anything has changed, has that been brought about by much has been said about the culture at NASA and the can-do attitude at NASA that perhaps contributed to the Columbia tragedy?
I would say our procedures, Richard, are even more detailed now. We do more things. We're doing more detailed inspections with better equipment on our wing leading edge and as well as the nose cap on the orbiter. As far as the attitude is concerned, everybody, you know, Columbia obviously hit us like a punch in the gut, so everybody is very dedicated to doing it right. We have reviewed all of our procedures. We have added a lot of steps to the procedures, added new inspections that have to be done. There is some new processing to do with the orbiter boom sensor. There has been some instrumentation added to the orbiter. So with all that, yes, there's been a lot of added work, and we're taking our time about doing it like we always do. Okay, right here.
Guy Guglielmo from the Washington Post. John, could you describe what kinds of effects weather has on a launch and what sort of discriminates between go and no-go as far as weather goes?
I'll do the best I can, although I'm not a meteorologist by degree, and my apologies to Kathy Winters if I misspeak too far. So I'm going to make sure that I don't go too far on a limb with my expertise in meteorology. We of course have to worry about winds at the launch pad. You don't want to have the whole shuttle stack. I know it's difficult for people to conceive that a 4.5 million pound vehicle could be moved by much wind, but it does happen. The vehicle does crawl as it starts to lift off. So we have to worry about those. Usually what is more of a driver from a weather perspective for us is crosswinds during a return to launch site landing. We have to worry about those. The other aspect, of course, is rain and clouds. Obviously we're not going to lift off through rain. The tile just can't take that. We have to worry about thunderstorms within 20 miles because of the implications of that storm moving in over the area, or perhaps the anvil head of a thunderstorm coming over and obscuring. We also have we have all these new cameras located around that have to be able to see the vehicle, particularly for these first two missions, but have to be able to get a very clear view of the vehicle during its ascent so that we can see if any debris is liberated from the external tank and hits the orbiter. So I think, yeah, that's about as far as I want to venture into meteorology today. Does that help? Okay.
Okay, Randy again? All right.
Randy Avera, Randolph Publishing. The Columbia Accident Investigation Board had looked into the coordination of engineering and operational issues on the Space Shuttle from Kennedy Space Center between KSC and JSC. And I understand that the JSC resident office has a new name. Could you also elaborate about changes in the procedures between Kennedy Space Center and Johnson Space Center during normal processing periods, as well as during days leading up to countdown and into countdown?
Okay. Yeah, that's a good question, Randy, because what was called the JSC resident office is now the Orbiter Project Support Office, and that reflects the real nature of the job that they have to go do. We want to coordinate the way the program is arranged. You have the shuttle program, and then you have the major projects of external tank and booster and orbiter underneath that. What you're seeing is a lot more coordination between the Orbiter Project Office at Johnson Space Center as well as the processing folks here at Kennedy Space Center. Now there's supposed to be a delineation between ground processing and orbiter design, but because the orbiter design folks represented by the Orbiter Project know so much about the design of the orbiter, they can give a lot of information to the ground processing folks, and the ground processing folks know a lot about how the hardware works, and they feed that back to the Orbiter Project, the designers. So the Orbiter Project Support Office, after the Columbia accident, has been increased by 100%. So there are a lot more people now doing that liaison work, not to mention there are more meetings and telecoms that go on between Johnson Space Center and the Kennedy Space Center. So I would say there's been a significant increase in the coordination that has to be done.
Okay. The organizational chart, where does the new was it OPSU, where does it fall into the new org chart? Is it where it used to be, or is it at a different level where it has a definite streamlined energy to get the job done correctly?
It now shows up usually on a KSC org chart where it may not have done that before, But its position is the same. We report directly to the Orbiter Project Support Office, OPSO, reports to the Director of the Orbiter Project, Steve Polis, and then we, on a daily basis, talk with the head of shuttle processing and shuttle processing engineering, between Mike Wetmore and Charlie Abner. We touch base with them every day. We sit in their meetings. We know exactly what's going on. So,
okay, thank you. Any other questions? Okay, not seeing any. Just a programming note at 3 o'clock today, Eastern Time. I have a discovery processing overview, and that will be with Stephanie Stilson, who is our discovery vehicle manager. She'll give us some very specific information on what the orbiter discovery itself went through prior to this mission. Then at about 4:30 today, or as soon as the mission management team completes its launch minus 2-day review, we do have our STS-114 pre-launch readiness press conference in this room. Thank you very much. Right now we have a discovery processing overview briefing with Stephanie Stilson, who is the discovery vehicle manager. She has a presentation that she'll be making, and then we'll go to questions after that. Stephanie?
Great. Thanks, Bruce. Good afternoon. What I'm going to do is I'm going to talk at a high level as to what we've done to get Discovery where she is now, ready for launch. And then I'm going to run a video where we'll be able to talk in a little more detail about some of the things that have happened. Back in August of 2001 is when we landed from our previous mission, STS-114. At that point, we were slated to go into our maintenance period, which is a regularly scheduled event, an overhaul of the vehicle that happens every 7 flights or 3 years, whichever comes first. At that point in time, back in 2001, we were not sure whether we were going to do that maintenance period activity at Palmdale, where it would normally occur, or whether we're going to move the activity here to Kennedy. So there was some uncertainty there waiting for the agency to decide where we would go with that. And then in July of 2002, they made the decision that we would move that maintenance period activity to Kennedy full-time, which was great news to us. That's what we were looking forward to. We had the team here that was ready to do the work, so we were ready to go with that. Officially, we started that maintenance period, modification period, in September of 2002, September 1st. And at the time of the Columbia accident, we were actually right in the middle of that processing for a maintenance period. It was slated to take us about a year to get complete. So in the February time frame, we were about halfway through. And we were doing things like wire inspections, over 150 miles of wiring on the vehicle. We were going in and inspecting, looking for any damage, repairing damage, also working on doing some wire separation and so forth. And I'll give you a little more when we have the video on that. Structural inspections as well were another key component. Looking at the vehicle's substructure, making sure we didn't have corrosion, stress, cracking, fracturing, those kind of things. And I do have to say, when I talk corrosion, I'm talking very minuscule. We use a 10x magnifying glass to see that corrosion. You're not talking about corrosion that you would see on an old automobile in a junkyard. So I always wanted to clarify that a little bit. And major modifications on the vehicle. We had the multifunction electronic display system, MEDS, which is the glass cockpit. That was probably the largest of the modifications that we were slated to do. We also upgraded our mass memory units to solid state equipment, which was a good thing, and increased our payload capabilities with NPLM cooling and also avionics bay cooling to support the mid-decks. Many of our major components on the vehicle were removed during this time frame. The forward reaction control system was removed, sent down to the hypergolic maintenance facility for its overhaul. Also, both of the OMS pods as well. The main engines come off every flow. That happened as well, and we worked those here through our engine shop. The reinforced carbon panels on the wing leading edge were removed, and in the process of doing that, we sent those off to the vendor for inspections and refurbishment there. While they were off, we did a full refurbishment of the wing leading edge, the spar area, stripped it down to bare metal, reapplied Corapon, looked for corrosion like I mentioned before, and then repainted that as well. Rotor speed brake was another big one, first time activity for us. We actually went in and had to pull off the panels of the rotor speed brake so we could get to the actuators. There was some concern that the actuators we had may have had some issues, degradation, based on some results they saw on Atlantis with some actuator inspections they did. So we felt it was the right thing to do, go pull off those actuators and replace them with new ones. The actuators themselves, I say new because they had never flown. They weren't brand new by any means. They're probably about 15 years old, but they had never seen flight before. So we did that with all 4 actuators. The body flap itself at the aft of the vehicle, and once again the video, I'll point these things out as well. Remove the body flap and replace those actuators for basically the same reason, to make sure we didn't have any degradation in the inner components of those actuators. and the orbiter docking system was removed. And that was put in the transfer aisle in the orbiter processing facility and worked on there. Obviously, that's Russian-owned hardware, so we did have some of the Russian folks come in and do some work. We did inspections, we did wiring work there. We repainted the inside of it and so forth. The orbiter maintenance period completed officially on September 1st of 2003, and with that was our power-up. And that allowed us to say, okay, we've gotten through our major modifications with meds and so forth, and we've powered the vehicle back up, and we're ready to start getting into our testing portion. Now, obviously, based on the accident and what came out of the CABE report, there were other modifications we had not been planning to perform that now all of a sudden were out there. The boom, wing leading edge sensors, additional spar protection on the wing leading edge, and also the new ET separation camera, the digital camera. Overall, the amount of work that was done was tremendous. 3.4 million man-hours of work during this flow to get us to where we are now. Time period was approximately almost 4 years total. And a standard flow that you would think about is about 250,000 man-hours, so a great deal of work has been done. 25,000 parts have been removed and replaced. 7,700 connectors, demated, remated, situation like that. And over 1,900 tile have been removed and replaced. And to put you in perspective, to understand that on a normal flow, you usually replace about 100. So a great deal of work. And a lot of that with the tile work had to do with getting to areas where we could do those structural inspections that I mentioned, looking at the surface of the vehicle. Testing perspective, we had about 8,000 test requirements, and that's basically the power-up checkout of all the work that we've done to that point. Normal flow is about 4,000. So once again, twice as much testing as we would normally do. Once we finished all the work in the OPF, we were ready to roll over to the vehicle assembly building. That occurred on March 29th. And at that point, the vehicle was ready to be mated up with the external tank and the solid rocket boosters. And we eventually rolled over to the launch pad on April 7th, got out to the pad, and as I'm sure everyone's aware, we went through our standard processing, and we also added in a tanking test so that we could verify the modifications that were performed on the tank and see how the tank was going to react to the changes that were made. And we ended up seeing some ice buildup in some situations that we weren't comfortable with based on, we thought we had modifications that would take care of those. Made the determination that we would go in and add an additional heater to the liquid oxygen feed line bellows area. And we contemplated, can we do that work at the pad? Does it make sense? And no, it didn't. From a safety of personnel and hardware, it was not a smart thing to do. So looked at doing the changes to the tank that was currently slated for the 121 flow. Since it was already in the VAB being processed, go ahead and get a jump start on that work and then roll back the 114 stack to the VAB and allow us to remove Discovery from the stack, put it in the transfer aisle, and then eventually mate it up with what was the 121 stack, now becoming the 114 stack. So rollback occurred on May 26th. We demated, got reconfigured, and then on June 15th, we were ready to roll back out to the pad for what I hope will be the last time if hurricanes stay away from us. And at this point, I think I'll roll the video and talk a little bit more about what I've covered and give a little more detail where I haven't done so already. And before I start, let me say, first of all, this video goes very fast, so what I'm going to do is I'm going to pause it along the way so I can explain what you're seeing, because if I try to explain it, I talk fast enough already, it's going to zip by before you even know what I'm talking about. So bear with me and we'll do the best we can. First thing you see, power up. First time we powered up after all the modifications, so it was a big time for the team. A lot of excitement there. Okay, first pause here. What you're looking at is the aft of the vehicle. These are the two compartments for engine number 2 and 3. And the reason I want to show you this is this is the body flap here. And we're reinstalling after replacing the actuators that you see in these areas. Okay, stop this again. RCC panels. What you're about to see is they're installing the first RCC panel back onto the vehicle after they've gone through all their refurbishment back at the vendor and so forth. So it was a very big occasion for us to start putting the vehicle back together in that area. You're looking at the wing leading edge, and the attachments you see there are called spar attachments, and basically the RCC panels hang on those attachments. work up here on the nose cap. And in addition to the RCC panels from the wing leading edge, we also sent off the nose cap and chin panel. They're also made out of reinforced carbon-carbon. So those all came off the vehicle and went back to the vendor as well. What the technicians are doing here are building back up the blankets and the insulation that are inside the nose cap prior to installing it on the vehicle. Okay, rudder speed brake. What you're looking here is the actual vehicle, so that's the vertical stabilizer of the vehicle. The panels are off. This is one of the 4 actuators that we removed. First time effort for us at Kennedy Space Center, had never been done except for the original build. So a lot of work and effort to go in there and understand the best way to build it. Certain GSE had to be built up, ground support equipment had to be built up in order to allow us to install these new actuators. Over docking system coming in, I told you we worked on that in the transfer aisle, bringing it back into the bay. Forward reaction control system, pulled that off, sent it down hypercolic maintenance facility, did refurbishment and wire inspections and so forth there. OMS pods being reinstalled after processing at the HMF. Left-hand pod going on the vehicle. Their left-hand pod. Wire inspections. I talked a little bit about this already, but I wanted to give a little more detail. Besides just inspecting wire, which you can see is a very time-consuming task. You're going in conductor by conductor and looking at any potential damage on the outer coating of those wires. We also went in and did modifications where if we had redundant paths for a certain system in one harness, one wire harness, we separated them and broke them out into separate harnesses. The reason for that is if you had some type of short or malfunction, you didn't want one path to affect the other, and therefore you'd lose your redundancy. So that was a big modification to go in. And obviously you've got wiring running from the crew module all the way back to the aft of the vehicle. So a lot of work there to make that happen. Also installed additional protection around those wire harnesses, taping and also convoluted tubing, which is like a plastic tubing, so that once we did the inspections, we could better protect them because we're doing work in the area. You could have collateral damage, meaning I could be working on one system and actually accidentally bump into wiring and do some damage. So that all takes time out of our processing flow. We'd rather protect it so we don't have that happen. I'm going to show you the mid-body of the bay. You can see it's pretty well torn apart. We took out tanks and panels and so forth, put in access. That was to allow us to do all the wiring inspections and structural inspections within the bay. It looks rather empty, and it was. Looking here at the wing leading edge, this is the underside of the vehicle. These are RCC panels, and you'll see there's a couple openings here. It's just showing you the process of us getting those panels reinstalled. Okay, this is a good one. What you're looking at here is this is the floor of the orbital processing facility, and you've come up into one of the main landing gear wheel wells. So what's happened is the technician has crawled up in here, and you're going to see a door through this way that gives her access into the inside of the wing. And she's actually installing sensors for the wing leading edge sensors, which were a return to flight modification. And you'll see the tight quarters she worked in for a very long period of time. Okay. Orbiter boom subsystem. This picture is of the boom in the offline lab prior to us installing it in the vehicle. Of course, made by Canadian Space Agency and brought to us. And very good success with brand new hardware. Once again, return to flight modification. Windows. Colonel Jim Kelly, one of our crew members, doing an inspection of windows. We did replace all of our windows, and Windows 1 and 6 were replaced with thicker pane windows, and that's to protect us from debris during booster separation. So that's a new modification. Most likely we will eventually replace all the windows with these thicker pane windows. However, it was most important to do it on the outer windows because they see the most impact. This is our rollover from the OPF to vehicle assembly building. A great time for our team, a lot of excitement. And now we're in the process of mating to the external tank. Very tedious, time-consuming process to make sure we have it lined up exactly right. This is the ET separation camera being installed into the orbiter. That allows us to take digital photographs at separation. Basically, during ET separation, that camera takes, I believe it's 24 shots, one every second of the ET falling away from the orbiter. That data is now digital. We've always had that ability to see that imaging. It's just we had it on a 35mm capability. So we could not look at the information until we landed. So now we have the ability with this digital camera, as soon as the crew gets Discovery on orbit, we can downlink the data via a laptop to mission control and let them see if there were any concerns with the ET moving away from the vehicle. Roll out to the pad, first time around. It was a very nice day. I'm sure a lot of you guys were out here. It was a very good time to be at Kennedy Space Center. Very slow process, takes about 8 hours total. Crawler doesn't move any more than 1 mile an hour. Tanking test, talked a little bit about that. Tanking test itself gave us the data we were looking for. We wanted to see how the tank would react to tanking. That's not a normal thing we've done in previous flows, to go ahead and run a tanking test. But as you're well aware, it was a good thing to do. We learned a lot of important things about the behavior of the tank. And that drove us to realizing we would need to swap tanks and make a modification. So this is the work being done on what was the 121 stack, doing the installation of the heater mod. These are technicians working on that. That told us we needed to bring the vehicle back, so now we're going to start rollback. Of course, the team wasn't real excited about that, but they understood it was an important thing to do. It was the right thing to do. Slow process going back just like going out. Still working here. This is your LOX, speed line, bellows area, so they've just got it covered up so they can do work in that area, protect it from any particles, keep it as clean as you can. That's trying to set up a mock clean room environment. And now we're removing Discovery from the 114 stack, or what was the 114 stack, and bringing it in to mate with its new stack, with a modified tank. And this is your forward bipod area, so they're doing the attachment work there. And then we're ready to crawl back out to the pad. We're launching off of pad B. Here we are. We actually brought the payload out to the pad first. You'll see the payload canister installation area. It's empty because the payload had already been installed. And so we brought that out, had the payload installed, then brought the vehicle out, and then inserted the payload. And that's all I have for video, so I think we're going to do some questions now.
All right, let's do. Please wait for the microphone and give us your name and affiliation. Okay, Mike, on the front row right here.
Hey, Mike Schneider, Associated Press. Just wanted to ask you, you had the shuttle fleet grounded for 2 years, for over 2 years. Then you had a delay from a May launch. Then you had a rollout, a rollback, a rollout. And then last night you had the start of the countdown. Tell me how you felt last night.
Felt we were finally here. Is this really happening? Are we really going to launch? Because you're right, along the way, so many times we had our hopes up just to find out that we would have to delay for numerous reasons. We had, of course, hardware problems. We had new modifications that had to be installed that we weren't aware of at the beginning of the flow. We had hurricanes. So a lot of things had been discouraging us along the way. So to be at this moment now is just tremendous, and it leaves me with goosebumps every time I think about it.
Okay, thank you. Other questions? All right, let's go back here down the aisle.
Hey, Settler, Richmond Times-Dispatch. Can you talk a little more directly about why Discovery was chosen for this mission? You alluded to some of it.
Okay, sure. Originally it was Atlantis, and there was plans that Atlantis would be the return to flight vehicle. And then based on the problems that we found with the rudder speed brake actuators, it was determined that Atlantis would also have to make that change, put in new actuators. So because we had already been working towards that and we had already started that work, we actually at that point were ahead of the game compared to Atlantis. And so it made sense at that point from an agency perspective that we were now farther along. No one expected it to be that way, but it did. So lucky for the Discovery team that we got put in the spotlight.
Okay, other questions? Okay, let's go up to the other side of the room here. All right.
Richard says, Community Daily News. You talked about thicker windows. How much debris will the shuttle be hit with on launch?
I can't really quantify that. I know obviously we've done the modification things to prevent there from being much, but we can't completely wipe out the possibility of debris, whether it's ice or foam or anything you might even see on orbit. So I can't quantify what we think we will see. That would be a better question for the Houston folks.
All right, to the back. Irene?
Thanks. Irene Klotz with Reuters. I have two questions. The first is, although the shuttle has gone through, or the shuttle program has gone through two tanking tests, could you talk at all if you have any particular concerns, or at what point in tanking will you feel confident that this tank that's on Discovery will live up to its expectations?
Sure. We have a team, an ICE team, an inspection team that goes in as soon as we're tanking, and they go and do all their inspections looking for, like you mentioned, anything, ice and so forth. So I have full faith that they'll do their job and let us know if they see anything that's not the way it should be. I don't expect that will happen. I think what we've done so far with having the tanking test to show here's what's going to happen on the day that we actually tank for flight. I don't expect us to see anything off nominal at all. But if we do, we'll address it. But at this point, I think we've done everything that we need to do.
Those were some pretty impressive numbers you tossed out about the number of how much time it's taken to prepare the vehicle. And I'm wondering if you have a sense yet of what it's going to take to turn Discovery around for its service as a backup on the 121 mission.
Well, that actually will be more like a standard flow because we won't have modifications and things, inspections to the extent that we did during this maintenance period. However, obviously with needing to be prepared for a potential crew rescue, we will be accelerating the beginning part of our flow. We will be working around the clock 7 days a week, 3 shifts a day. And so that takes additional manpower to do that. So I don't know what the numbers would be, but I can say that until we know for sure we do not have to rescue Atlantis' crew, we will be going full throttle. And then at that point, if we get a wave off, we will back off on our resources because we will have a great deal of time left to do the remaining work before our actual launch date.
Any other questions? Okay, right there. Mm-hmm.
Dan Majors, Pittsburgh Post-Gazette. About the cameras, how many new cameras are aboard this craft, and are they all digital now?
No, there's only one new digital camera, and that's that ET separation camera that I spoke about. There's still 35mm and 16mm cameras, but those had been flown before. So this is the digital camera. There's only one digital camera now.
All right, let's bring it back to that front here. Kelly?
Kelly Young with New Scientist. If for whatever reason they don't make the July window and looking at September, is there any modifications that could be done during that downtime?
At this point in time, I'm not aware of any requests to do any modifications. Now, the folks at Houston Design Center could come up with something that they felt was important enough to do if we had a downtime, but I wouldn't expect that because of the short period of time there and the fact that, gosh, they've done such great work so far to get us all these return flight modifications that we have now. So I think they've pretty much exhausted it. You can always improve the vehicle. So yes, you could go in and make changes to make it better, but is it really a safety of flight issue? Most likely not, because we've addressed those fully.
Okay, let's bring it over here. Stefano?
Stefano Coldan, Popular Mechanics. Could you go over the actuators that were installed in reverse? Could you explain what happened?
Absolutely, sure. As I mentioned before, we were installing new rudder speed brake actuators based on some test results they'd seen offline. And after we had those actuators installed, while they were doing other testing at the vendor, they found an actuator that had a planet gear installed inversely, so it was not installed correctly. They ran tests to see what that meant, if that was a real concern, and bottom line came back and said, we just don't feel comfortable without going in and making sure that the actuators currently on Discovery don't have that same issue. So we did go in and pull off actuators and do x-rays here on Cape Side that allowed us to know for sure that the actuators we had were built properly. So we did the right thing and went in and checked and made sure.
Go ahead, Stephanie.
Yeah. And what would have been the consequence of installing them in reverse? For Atlantis, what could happen if you have the actuators installed upside down?
Well, the main concern would be obviously that it would not function properly when you needed to move the panels of the rudder speed brake. Now, the testing they did was under numerous cycles. So the likelihood was low that you would probably see a failure, but we weren't willing to take that chance.
Okay, thank you. Randy, right here.
Randy Avera, Randolph Publishing. Two quick questions. NASA has replaced Windows number 1 and 6 on Discovery, correct?
We've replaced all the windows, but 1 and 6 have the new thicker pane windows.
And so Windows 2 through 5 have the original fused silica windows.
Yes, sir.
As far as the composition is concerned. What was the logic in not replacing those? Was it lead time for availability of the window panes?
We did not have thicker pane windows to support the entire vehicle, and really the critical areas were 1 and 6 for that, and so that's why we chose at this point to do 1 and 6. Down the line, very well could go in and change those other windows as well, and we probably will.
And my last question, in regard to the rudder speed brake, the actuators on the speed brake, the vendor had installed the planetary gears in number 2 and number 4 actuators upside down. But for the future, as a flow manager, you could agree that having to remove line replaceable unit and send it back to the vendor is not conducive to making a reasonable schedule and safety. What has NASA done, if you could comment in any form, to have more on-site quality control at the vendors and suppliers so that that type of event could be prevented?
Although I'd love to answer that, I'm really not the right person to comment on that because I'm not involved with the work that's done at the vendors. We pretty much get the parts here and then go work with those parts. So I'm afraid that I couldn't answer you properly on that.
All right, right here, second row.
Robert Goss, Interspace News. How many of the RCC panels were replaced, and what was your criteria for determining whether or not they needed to be replaced?
I believe we only had to replace 2, and that is because we sent those off for the testing for the accident. I don't believe that we had any that had to be replaced just based on the condition they were in. It was because we sacrificed those panels for the testing that was done.
What would be the criteria, though, for removing a panel? What kind of defects would you be looking for?
If you had to replace it,
and whether a panel had to be replaced or not.
The structures and the thermal pressure system community have strict criteria of pinholes, dings, coating loss, and those kind of things. I don't know the specifics behind each of their criteria, but it's basically the composition and has it eroded or has it broken down in any way.
Other questions? Okay, I don't see any other questions. All right, just a programming note. Coming up as early as 4:30 today, we have our STS-114 pre-launch readiness press conference. Stand by for that because that is not an exact start time. It will begin as soon as the mission management team finishes their meeting today. And then tomorrow morning, we have another countdown status briefing at 10 o'clock in the morning. Stephanie, thank you very much.
Thank you.
Thank you.
Good afternoon, everyone. Welcome to the pre-launch press conference for STS-114. On our briefing this afternoon, Bill Parsons, the Space Shuttle Program Manager from the Johnson Space Center. Bill Gerstenmaier, the International Space Station Program Manager from the Johnson Space Center. Wayne Hale, Space Shuttle Deputy Program Manager from the Johnson Space Center. Mike Wetmore, Director of Shuttle Processing at the Kennedy Space Center. Dr. Kunyaki Shiraki, the Space Station Program Manager from JAXA. And First Lieutenant Mendy Chavez, the Launch Weather Officer from the U.S. Air Force 45th Weather Squadron. And we'll begin first with the Shuttle Program Manager, Bill Parsons. Bill?
Well, we had another day of good review. I think we'll tell you a little bit more about that as we get through the questions. But what I would say is we do have one more day prior to the launch, so we'll meet one more time, I'm sure, and go over a few other things. But it's great to be here. It's great to be at this point in the return to flight effort. And I guess I would just say to Bill Gerstenmaier and the International Space Station crew, it's probably time for them to get ready. I think we're on our way.
Thank you, Bill. And Bill Gerstenmaier.
Thanks, Bill. And again, it's my privilege to be here representing the International Space Station team. We're fully ready to support the launch. The ground teams are ready. They're prepared talked to the flight crew on Saturday, and they're fully ready on orbit. They've been practicing the pitch maneuver and taking pictures. They've been preparing the station. We're practicing many techniques that they're going to have to use during the mission, so they're fully ready and prepared, and the ground teams are ready. So we're here to support the shuttle team as needed, and we're really glad to be here. And again, really, it's a neat experience to be here and to get ready to see the shuttle get ready to go launch.
Thanks, Bill. And now to Wayne Hale. Wayne?
I'm just excited to be here today. It's like Christmas is coming. It's really a thrilling time to be here, counting down for the next space shuttle flight.
Mike Wetmore from KSC.
I can't tell you how excited I am to be back in another L-2, and I look forward to many repeats of this meeting. We aren't working any major issues right now, so we're ready to go.
Thanks, Mike. Dr. Shiraki from Jackson.
It's my pleasure to be here, and actually, I would like to express my thanks to NASA people for coming up to this date of 114 to prepare for launch the day after tomorrow. And this flight is very important for the continuation of the space station program, as well as the completion of the space station. So I would like to express my thanks to NASA people.
And to Lieutenant Mindy Chavez from the 45th Weather Squadron.
Hi, good afternoon. It's a pleasure to be here. Weather for Wednesday, as we've been saying throughout the entire week, still is favorable. Still just a 30% chance of KSC weather violating launch criteria. That's all for right now. I'm not going to go further.
No, that's good. All right, we'll take questions now. Please be sure to give your name and affiliation once the microphone comes to you as we call on you. So we'll start here in the front with, where's that Mark Handler? Over here, right here with Jay.
Jay Barbary with NBC. Could you tell us, Lieutenant Chavez, the threat coming from the other storm down there, what's the latest information on that and its arrival possibly here?
Sure. If we could pull up the satellite picture, please. The last information that I've received regarding the storm is still Tropical Depression number 5, so it hasn't gained in strength or warranted the name yet. The National Hurricane Center is, the track's a little bit hard to see on the satellite picture, however. The National Hurricane Center hasn't deviated from its track. It still seems to be relatively far south. The latest model runs they were saying, worst case, if the storm were to come over KSC, it wouldn't arrive until early morning Monday. So it's not too much of a player for us.
Marcia?
Marcia Dunn, Associated Press for Wayne. I'm wondering if you could talk a little bit about your comfort level with any of these so-called acceptable risks going into this flight, and why you think now is the time to finally go fly.
Marcia, we've had a series of discussions over the past several weeks going through all the risks, not just the debris hazards, which of course have been on everybody's mind, but all the other associated intricacies of space flight, the shuttle vehicle and the launch systems, and I think we are ready to go fly now. But.
Risk issues that are out there.
Okay, well, you know, there are risks in space flight, and obviously as time goes on, one hopes to improve the system, and we will continue to improve the space shuttle system to reduce the risk. So in the future, we will have less risk. I think that goes without saying. There comes a point in time when you think, when you decide that we have reached an acceptable level of risk to go carry out the mission that we have, and I think that we are at that point. And that does not mean that we won't be safer, but we're not going to be so much dramatically safer in the next short period of time that it's worth our while to delay. Now's the time to go fly.
All right, let's take one here from Irene before we go to the other side.
Irene Potts with Reuters, also for Wayne. Could you please describe how the NASA organization that's going to be launching on Wednesday is different from the group that sent STS-114 into orbit 2.5 years ago?
Well, individually, I think almost the entire management structure has been changed out. Technically speaking, the folks that are the engineers that have the data, that have the real smarts that make this program work, are still in place. And if anything, they've practiced more and gotten smarter. So I think that they are a lot more empowered also to bring issues to the management team. So when you talk about the changes that have been made, and I'm talking not the technical changes, but the people changes, it really has to do with the management structure. And I think that's been pretty well talked about. We are much more open. I guess today would be a good example of that. We had an L-2 day meeting that lasted about 3.5 hours, as opposed to much shorter than that before the accident. We had lots of discussion and debate. We had numerous people come into the microphone to ask questions and talk. I think that's just a new symbol of the openness and the encouragement that we have to get everybody comfortable, to make sure that we've left no stone unturned as we get ready to go fly.
All right, let's come over here. Jim, Slade.
Could you quantify for us, in your own terms, the real importance of the success of this mission to your station?
Well, obviously we can't continue assembly with Space Station without the shuttle, and this mission is the beginning of that. It's truly, in a sense, a test flight for the shuttle program, but if that goes well, we're going to change out some things, the control moment gyro, some other items on station. And probably more importantly, a lot of people talk about bringing new supplies to station. We're going to return a lot of items from station, which will be really important to us. It's probably almost as important for us to get the control moment gyro back, to understand what failures occurred in it. We're going to return the Russian electron unit to see what failures occurred in it. We have a GPS antenna that we're going to return, and all that information and hardware returning will allow us to get smarter, to understand what hardware we need to build and to get back into the assembly sequence. So we've got kind of 2 flights here with the shuttle program to practice getting back into assembly. Then the 3rd flight, we really kind of hit it hard. But this is probably the most pivotal, critical moment to continue assembly that we've had.
Let's follow up. How close to a critical point are you in the absence of this mission? Would you be on the cusp of doing trouble?
Again, what we've been doing with station is keeping station in assembly-ready configuration, and we've done that for the past 2 years. We're still stable, so if this mission doesn't occur this week and it moves a couple months to the right, we're still stable. There's not an issue with that. So it's important in the sense that this mission occurs. Does it absolutely have to occur this week and on this particular day? No. We've done what we said we'd do. We keep the station in assembly configuration as long as we can, and the teams have done a phenomenal job of doing that. But we're ready when the shuttle's ready.
Okay, Tracy.
We just got a bunch of documents released by NASA saying that we had a discussion opinion with the SRO about the program code. And I'm wondering if you can explain that for me. There's a lot of jargon in the document, and talk about where you stand with that dissenting opinion.
Let's see. It's a hold-down post or T0? Okay. Because if it was a hold-down post, I was going to have a little bit of a problem. And Wayne can probably add a little bit to this too. But as we've looked at the T0 umbilical, we had some issues on a previous flight where we didn't have some ordnance that fired, the backup ordnance fired, and so we had to go down and make sure why that occurred. We did a great deal of study. The Kennedy team just did a huge effort to understand the root cause of that. They determined the root cause of that, and it was a lot to do with corrosion, and the fact that we hadn't changed these pins out, or these cables out after each flight, which we had done in the past, but we had determined that we didn't think we needed to do that. Apparently, corrosion had built up on these pins and caused us this issue that came about. They were able to trace that down as one of the root causes, but as they did go through that whole process, they found out that we needed to be a little bit tighter on our tolerances within the T0 because it is so critical to launch, and so they continued to look at ways to tighten that T0. We had a few people from I guess it was a combination of safety folks from JSC, KSC, and I think Marshall as well. And again, correct me anytime I might get this wrong, but they came forward and they wanted to see pin engagements to be about a ½ inch, I believe. It turns out that in this T0 right now, we have a ½ inch pin engagement with all the tolerances that we needed and everything. We're going to continue to look at improving the T0 interface and to make sure that those tolerance stack-ups don't get us and that we stay within that ½ inch pin engagement. But they were concerned that we needed to do a little bit more design change before we went and flew 114 to make sure that we had that ½ inch pin engagement. We discussed that at many forums. Many forums prior to it getting to the PRCB. Then it came to the PRCB, we discussed it there. And it was so important, again, these gentlemen felt so strongly about it, we felt it was important to bring it to the flight readiness review. We did that and gave them an opportunity to voice their opinions and tell why they thought there was a redesign required. At that point in time, the shuttle program also offered why we thought we were safe and that we could go fly this, and that we had a forward plan to go improve this along the way. And everyone determined on the board that it was acceptable and we should press forward. Did I get that close? Everything. Okay.
I guess, Bill, the only thing I would add is included in concurring with the program position were the Independent Technical Authority, the NASA Engineering Safety Center, and the general safety and mission assurance community. So it was just a few individual dissenting opinions, and the wider community listened carefully. I'll tell you, the independent assessment that was actually kicked off by the Marshall SNMA folks resulted in a lot of improvements in our processes here. But in the end, these last couple of recommendations, the general community did not agree with the dissenting opinion and accepted the system as it is today to go forward.
And I wouldn't say they didn't agree. They just didn't believe it needed to be done prior to STS-114. We will continue to look for ways to reduce that tolerance stack up and improve this interface. But for right now, we believe we have a good interface and that we're ready to go fly.
Okay, let's go to the next row. Craig?
Craig with Aviation Week. Wayne, a moment ago, you used the word debate. Were there any dissenting opinions on any topic today, and what we referred to in use of the term debate?
Well, let me see. We had so much fun. I'd be hard-pressed to put my finger on any one thing. I think that what we did have a spirited discussion, maybe better than debate, on 3 or 4 different topics. We have 1 or 2 that are going to come back tomorrow for a little bit more information. We're going to meet, as we've said many times, the mission management team, and today was the first meeting of the mission management team for 114. We're going to meet every day, and we're going to talk about topics of interest, concern from all comers. And we saw that today, and there were some people that had questions that need answers. All those answers were forthcoming. There were a couple of topics where we didn't have the right expert present. We've set up some offline things to get people with concerns with the experts so they can get their questions answered. And I think tomorrow when we come back together, we'll have tied up all loose ends. And that's the sort of thing that I think an organization that's trying to deal with these highly critical systems has got to do to operate safely in the future. Okay, well, let's see. We had a couple of issues that came out of the tanking test. You know, we've been talking about issues out of the tanking test for quite some time now. There are a couple of loose ends to tie up there. We had the discussion about going back and looking at the historical record of tile damage on the orbiter and how we're going to use our new damage assessment tools in the future to resolve any questions about whether or not we need to repair tile damage.
And that one was pretty much closed out.
That's right. I think we closed that one out. Let's see, what else? How can it have left my mind?
The Dollywood.
Oh, yes. They launched the balloons that we launch here at the Kennedy Space Center that we do analysis on to look at whether the winds aloft are acceptable to fly. You know, all rockets have to be very careful about their structural loading and heating. There's one new test that we've added since the Columbia accident for heating on a certain part of the vehicle that we're having trouble passing with the balloons, and we think we may have put in an overly conservative constraint. Folks are off looking overnight to see if that's the case, and if not, what are we going to do about it? So we have a couple of loose ends to tie up, but I wouldn't consider them major. I would say that we do have to resolve those issues before we go flying. Another one was some engineering review of some of the new tools that we have for the EVA crewmen when they go spacewalk. If we have to do a repair to the thermal protection system, and not all of that paperwork is closed out, and we had a little bit of discussion about what does that mean in terms of our system, and we got the assurance that the engineers were going to be working overnight to review those tests and reports to make sure that there wasn't anything left out that we needed to have done before we go fly.
And I guess the only thing I would add is we anticipate a very positive results tomorrow, but again, until we hear those, you know, we'll just have to wait and see. But it looks like they'll have everything closed out tomorrow.
Yes, right here in the front.
I'm thanking you for Washington Post for your bill on Mike. Could you describe the countdown today, the highlights of the countdown today, and what is it that we have to look forward to, and mostly what are the critical things that are going to happen tomorrow?
I think that one's mine. Right now, we just started within the last hour or so. We started loading of the cryogens that are stored on board the vehicle in order to provide power, reactant, storage, and distribution to the fuel cells, the liquid hydrogen and liquid oxygen that feed the fuel cells. That storage will take several hours and results in a pad clear. After that, we have some built-in hold time to allow a little bit of slack in case anything runs behind. We did get into the cryo load about an hour late, so we build in some slack time. We'll get into comm activation. Basically, from here forward, you see us bring up more and more systems to ensure that they're up and activated and working properly. There's some late stowage for flight crew equipment late Tuesday night. The RSS will roll back tomorrow night. That's one of the major milestones you're looking for. And then we'll do some final load preparations, and around 2 a.m. on Wednesday morning, assuming everything's still going good, we'll get ready for the final load of the vehicle. Our briefing, weather briefing is at, help me out with the time? 4:45 a.m. is the actual pre-tanking weather briefing, and that'll be the final call. And if everything's looking good, at that point, we'll do the loading of the external tank. You'll get down to about 3 hours before T0, the crew ingresses, if everything's still looking good. And then a beautiful launch around 3:45 is the start of the window. We're actually shooting for T0 a little closer to 3:51 on Wednesday afternoon. Does that answer your question?
Okay, I'm going to come back over to this side of the room. Sharice?
Yes, Sharice Dottin with the Palm Beach Post for, I think, Wayne and perhaps Mr. Parsons. This is about the safe haven plan, and I'm curious, given the value of the orbiter, the dollar value, and also given the potential value of engineering data that you might get if you brought a damaged shuttle unmanned back to Earth, have you given thought to instead? I know there are concerns about bringing it back to a populated area, but you've got contingency runways, I guess, at Easter Island, at DA Garcia, et cetera. Have you given thought to that?
Well, let's see. I guess we have given some thought to it. Our primary concern, however, is the safe return of the crew. And frankly, if we think that the shuttle is in good enough shape to make it through entry, and then we would want to bring the crew back on it, because even though the station is there for safe haven, you do put another crew at risk, another shuttle vehicle at risk from launching them. So, you know, we have this plan, which we hope we don't even remotely have to think about executing, to put a crew on a station and send a rescue flight up. But our primary concern is keeping the crew safe and bringing them back in a good orbiter. That would be our primary plan.
You know, over a year ago, we talked about ways that we might do the capability of auto land. We don't have that capability currently right now. We do have the capability to undock and then put the orbiter in the ocean. So right now, I mean, we just don't have that capability. It would be something that you would have to invest in, and it would take some investment and some time to go do that. And we don't have that capability right now.
Okay, right here.
John Kelly with Florida Today. For Bill or Wayne, I'm just curious about whether eco sensors was one of the issues that came up today, and with that being an unexplained anomaly, sort of what the go-forward plan there is. If you don't know what caused it, is it just something you have to watch and account, or what's the rationale on that one, on flying on that?
Okay, well, we did talk about that today. As you said, the low-level sensors, the engine cutoff sensors, are an unexplained anomaly. We changed out the black box in the orbiter that controls those sensors. We changed out a lot of the cabling. We did a number of tests, and we have not been able to finally determine what the problem was. However, that's on the tank that's in the VAB right now, and the real question is, can we use that tank for the rescue flight? The thinking is that we can. However, on the orbiter side, we have changed out literally all the cables and all the black boxes associated with it. So if there was a problem in any of that equipment, we believe that we've got it finally taken care of. The only debate is there something generic out there? And that, frankly, is one that folks want to talk about yet again overnight and come back and talk about tomorrow.
You know, John, when you have a UA like that, that's going to create a lot more attention to make sure that all the systems working properly. And I think what Wayne's saying is we're just paying really close attention to this right now to make sure everything is exactly like it needs to be, and we have all our backup systems working properly and everything. And because of the UA, that just created that attention.
Okay, this gentleman right here. Randy Avera with Randolph Publishing for Bill Parsons. During launch countdown all the way through T0, could you tell us what is new about problems that could arise that aren't clear violations, launch commit criteria violations, but are questions that need to be coordinated back to JSC? It could be a design question. What's new about the procedure for handling anomalies like that?
And being the shuttle program manager, I can throw this one off, and what I'm going to do is Wayne is in charge of he's the chairman of the mission management team. He's the one doing the countdown, working with the launch director and who works for Mike Wetmore. So I'm gonna let Wayne answer this. I'll help if I can, but right now I think I'll throw this into Wayne.
Thanks, Bill. Let's see. Well, first of all, we try as well as we can to develop very clear-cut and very comprehensive launch commit criteria that deal with just about anything that potentially could go wrong. But as you know, it's a complicated vehicle, and there's always things that come up, and there are sometimes design questions. One of the things that we've done not only at Johnson but also at Marshall is improve the engineering support from the engineering core group at both of those centers that represent the design element for the Space Shuttle. We have more of those people sitting in their respective support rooms, that is to say the mission evaluation room and the HOSC at Marshall, to make sure that if there are questions, that we have the right people in place to answer those questions as rapidly as we can. And we have beefed up our communication channel, and by that I don't mean the physical number of telephones or something like that, but I mean we've strengthened the management chain to be proactive and ask questions and to seek out the experts to make sure that we've covered all the issues more thoroughly. So we have increased quite a bit from where we were prior to Columbia, with having the engineers present, having the smart people connected into the team to provide answers if we come across a gray area question.
Okay, Stefano?
Stefano Collidan, Popular Mechanics. Mr. Parsons, a few years ago, actually it was in the mid-90s, you were talking very seriously about landing a shuttle automatically. And then that sort of went away. Why? I mean, what happened?
Well, I don't know if I can, touch all the appropriate points, because there's been a number of studies done throughout the years about this. I think that the fact is that it would require a significant investment, and then to test that auto land, then you have to put some people at risk, and then go do an auto land kind of testing that you would do as you return back from space. And so I think overall what we've determined is this is a human spaceflight vehicle. We have every intention of using it in that capacity. And we've always come to the conclusion that the investment and the risk involved in that was not worth the investment or the risk. And so we've always kind of did the trade-offs, risk versus risk, and always come down with this is a vehicle that we're going to bring humans back in, and we're going to let them fly it in for the last portions of the flight. And I don't know, Wayne, did you have anything you wanted to add? You've probably been around this as much as anyone.
The only thing I'd add is, when you think about having an auto land system in a conventional airliner, if things don't go well and the auto land system trips out, what do? Well, you apply power and you go around. That isn't really an option with the shuttle, so we've got to get it right the first time. And studies have shown having people in the loop really allows you to get it right the first time, better than the automated system.
A question right here.
John Schwartz from the New York Times. I guess this is for Wayne and maybe Bill. Mr. Harry said we have this plan we hope we don't have to remotely even think about in terms of shuttle rescue. Where on that scale of not remotely think about or maybe do is repair? Because it's still a work in progress, as you all have said several times, but you just mentioned the fact that it might come up. Where do you see it on the scale?
Well, you know, I probably overshot the mark when I made my comments a few minutes earlier, because we think about these kind of contingencies all the time, and all sorts of different contingencies. I think that's the hallmark of a really good team, to study the system very hard, to think about what might go wrong, and to develop plans, and not only a plan, but a backup plan and an alternate plan and a backup to the alternate plan, to try to have a capability. If something goes wrong, what would we do about it? As a matter of fact, that, of course, is one of the troubling aspects of how we got here, is why didn't we have a backup plan? So we have these plans. They're not perfect. They have their own particular problems in many cases, and it depends on the situation to which remedy you want to apply to the situation. Some cases we have really good remedies. Other cases we have limited remedies. And some of those remedies, well, every one of those remedies comes with its own costs and its own risk. So you have to weigh every case, you know, every situation on its own merits to see what remedy you would apply. And if we are fortunate and have done our work well, we will not have to apply any of these remedies.
Okay, we're going to come back along the wall here. Mark Thoreau.
Thanks, Mark Thoreau from the Houston Chronicle. I have a question and a follow-up, but the first question is, would it be fair and accurate to characterize your meeting today when it got spirited were discussions over issues that had arose from the past as opposed to someone walking in the room with something new?
Well, I was an observer, and Wayne was chairing the meeting, so I'll kind of take it from an observer's point of view as we watch this. These were people being interactive that are part of the board and part of the engineering community. It's things that we've discussed, that we knew we were working our way towards closeout. It was questions about, did we actually bring it to fruition? I think in the end that we realized there was a couple of things we wanted to talk about a little bit more. There's a few people that want to go off tonight and talk to some of the experts and bring back the data to the meeting tomorrow. And we think that again, it was very when we say spirit, it was the passion of what we do, and these engineers getting engaged, and managers asking good hard questions, and then just saying, hey, look, that's a good question. Let me go back and make double sure that I can answer that question. And so they went off to get with their crew tonight and come back tomorrow.
All right, come back here.
Dick Giuliano from CNN Radio for Mindy. Around the 3:50 time today, it seemed pretty overcast over the launch site. And I was wondering if you could describe how you expect conditions to unfold on Wednesday afternoon. Will there be clouds that will move away, or will it be mostly clear in the afternoon, or what do you think it'll look like?
For the afternoon of the launch day, we'll have the high pressure ridge moving back just to the north of KSC, which is actually working in our favor. It brings the winds out of the southeasterly flow, which again is one of the favorable conditions for launch. We again expect a sea breeze to migrate from just offshore and moving inland, and because of the sea breeze and the convergence zone, that's where we expect the thunderstorms, and that's our main concern. Just waiting for the thunderstorms to move far enough inland to not affect the launch site out here. But with respect to clouds, it should be scattered, no real ceiling for the day. Correct.
Dick Radner from ABC Radio. To follow that up, could you have gone at the launch time today? Would the clouds violate, or would anything else in the weather violate your criteria?
with respect to the weather today, the clouds were thick, but due to the constraints, it's more whether the forward air and land observers. I think that is probably the issue which regarding to the clouds, whether they would have been able to see the shuttle. I don't.
Would you have been able to get the photography you needed?
I was in the meeting all day, and I frankly didn't watch the weather today. We didn't have a window. I didn't go outside, so I can't answer your question.
We couldn't watch today, so we just didn't pay a lot of attention to it. We're really worried about Wednesday.
All right, right here in the green shirt.
Greg Dobbs with HDNet Television. A question about the use of the space station as a safe haven. I think just yesterday, the crew on the space station said that they are capable of hosting the shuttle crew, 9 instead of 2 for 6 weeks. I think they said 6 weeks or 45 days. Number one, is that the outer limit? Number two, is the shuttle vehicle itself holding enough of everything from oxygen to food to extend that safe haven time if necessary? And number three, is one of the other vehicles, I don't know which one it is, Atlantis or Endeavor, already being prepared to be used as a rescue vehicle in the event of?
Well, let's see, I'll take the launch on need. Mike Wedmore could probably tell you this, but Atlantis is prepared and ready to go on a launch on need basis if required. It is well within the time limits that we have for hosting the crew on the International Space Station, and that is something we talked about today at the L-1. It's something, at the L-2. We'll talk about it again tomorrow, and that all has to align for us to be able to go launch on Wednesday. As far as on the space station, I'll turn that over to Bill.
Yeah, our latest calculations show we have about what we had at the flight readiness review, and that's about 56 days. And that overlaps with the shuttle, and Mike can talk about the shuttle piece.
Yeah, the numbers we provided today, based on a recent decision to change out one of the engines on Atlantis, is we'll be ready in 40 days after launch to launch the next mission. So we've got a couple weeks of margin, if I can use that word, as far as commodities on board the station to support our schedule.
Let's go up here, Mike.
John Johnson, Los Angeles Times. Was there anybody in the meeting today in the spirited discussion who said anything along the lines of, we can't do this yet, anything that, that you had to argue back against? And
Yeah, I would have to say, from where I sat at the head of the table, the answer there is no. We had a number of folks that had questions. We have 3 or 4 things to close out yet. But nobody stood up and said, no, it's not time, or we're not ready. It's just, have we done, the final last few things that we've got to get closed out? Now, I got to tell you that there are, of those items, if we don't get them done, we shouldn't launch. But, there was not that kind of discussion, if I can characterize it that way. Oh, you haven't been to one of my MNT meetings, have you? We're confrontational in a collegial sense.
All right, Mike?
Mike Cabbage with the Orlando Sentinel for either Bill or Wayne. You're talking today about the spirited discussions that you've had at the L-2 in wrapping up some of these issues that you've been talking about for a long time. And when you start to get back the imagery and some of the data from the cameras on ascent and from the boom sensors and that sort of thing, from the photography the space station astronauts are going to be doing of the orbiters' tiles, you're going to be seeing things you've never seen before. Have you talked at all about how you're going to wade through that information and how you're going to be able to arrive at some kind of a conclusion as to whether or not you've got something really to worry about, again, given still the level of discussion that's going on with some of these issues you have? No?
Let's see, how can I say it? This is NASA, and we have got a plan, and I think when I signed the latest revision to that plan, it ran to 300 pages of how we're going to get all this data, whether it's the ground cameras, the station cameras, the cameras that are actually flying on Discovery itself during the stack, the aircraft cameras, the radar, the boom sensor system. All that data is going to come in. There's a plan of when it's going to come in, who's going to look at it, what evaluations are going to be done, when it's going to be reported back to the MMT. The mission management team has done 13, I think it is, simulations And that's been a topic at every single one. We had a little offline discussion this morning, early morning hours. Some of the senior managers got together with me and we actually talked about this issue. So yes, I can say without a doubt we have a plan. It has been thought through and practiced and looked at in detail, and it's going to be a challenge to get through all that data, quite frankly. And you've got to recognize too that some of the data may not be black and white when they come out. You know, it may be kind of iffy, and so we're practicing on how to deal with that.
And as a follow-up to that, in cases where you don't have data that's black and white and it is iffy, and you have disagreement on what it means, I mean, I'm assuming you'll err on the side of caution, but can you talk a bit about how you plan to resolve those issues in those sorts of cases?
Well, we've thought a very long time about that, because erring on the side of caution, it's subtler than you might think. You know, if you decide that you need to go out and repair, you encourage a risk. If you decide you want to stay on the space station, you incur a risk. So erring on the side of caution doesn't always mean that you wind up being on the side of caution. So it's better to get a very precise answer to the best you can possibly understand it and make an informed decision at that time. And there is no doubt in my mind that we won't but have a spirited discussion and a thorough evaluation, and probably a lot of help and advice from all our leadership on this decision.
Lauren Lapenzino with Fox 35 in Orlando. This question would be for Lieutenant Chavez. Just getting back to the thunderstorms for one more second, if I could. Afternoon thunderstorms are sort of a way of life here in Florida, especially in the month of July. Could you touch on what would happen on Wednesday if a thunderstorm is imminent, and how that might affect the launch window or the timing of the launch?
With respect to the thunderstorms on Wednesday, due to the placement of the high-pressure ridge and the way that the sea breeze is going to migrate in, we're pretty confident that the storms are going to actually be closer towards Orlando and well outside of the 20 nautical miles of the shuttle landing facility. So they shouldn't really play an issue for us, just because of due to the fact that they're migrating westward and the way that the synoptic pattern is. If it were perhaps earlier or later in the season and the high pressure ridge had moved a little bit further north and south, and the thunderstorms were located overhead, then it would be much more of an issue, and the 30% would be much greater.
Okay, we've got time for a couple of follow-ups, and then we're going to wrap up. Jay?
Jay Barbie with NBC. What time are you going to meet tomorrow? How are you going to let us know if those items you're concerned about are closed out? And if you run into a showstopper, will you come back and talk to us?
1:30, there's going to be, I believe, a press conference, isn't there? And I'm getting the head nod. And if there's a decision that we have a big concern, be here.
Has the administrator agreed to do that conference tomorrow afternoon? Is that the one you were referring to?
I'm going to answer that question.
There's a 1 o'clock, 1:30, or tomorrow afternoon with the administrator, and then there's the post launch.
I think what we're saying, though, if there's an issue, if you don't hear anything from us, it means we resolved everything, I assume, and we're going to go into launch countdown. If there's an issue, we'll be back in here to talk to you about it. I'm pretty sure. So.
Okay, Marcia?
Marcia Dunn, Associated Press. Maybe for Mr. Whitmore, I'm not sure. In flipping through all the FRR documents, I happened to see that there was a launch lock bolt issue with the stowage platform. What's the upshot of that? Did that get resolved?
I'm going to defer that one to Mr. Gerstenmaier since his board cleared that issue.
Yeah, we looked at that and we did analysis. We assumed that the little lock isn't even there and present at all. And we did the detailed nonlinear structural analysis, and there's no issue at all with any of the hardware. So we're fully certified from an analysis standpoint. We're good to go fly, even without that bolt being in place.
Irene?
Irene Fox with Readers for Wayne. You've made transforming the waiver system one of your personal missions, and I'm just wondering if you could tell me now what sort of how many waivers, if any, you're going into this count having, and what they are.
Oh my. Okay. Yes. Yes. It's been my mission for 2 years to review all the waivers in the program that existed before the accident. And we had, let me see if I can quote numbers off. I'd probably get myself in trouble. We had something like 6,500 waivers at the time of Columbia against different requirements at the program level. Okay. And following our review, when we went to the flight readiness review 2 weeks ago, I was able to report that we had reduced that to 244. And since that time, I have to report that some people have come in with some additional waivers. Most of these were against the new equipment that we've got on board. I think the orbiter boom sensor system has got a number of waivers in what I would call minor areas. The point, however, is not the count. The point is that we have set a new principle that we are not approving waivers based on expediency, because we kind of want to go launch and it would get in our way if we really had to go fix something, kind of reasons. But we are basing any waivers that we have to any kind of requirement on a good, thorough engineering evaluation that says that at the end of the day, the risk is minimal or at least acceptable and certainly well understood. That's, I think, the right process to have. And I think we're going to continue in the future to try to bring as much hardware, as much of the shuttle processes into compliance with the top-level requirements as we can.
Are there any questions our Japanese media would like to ask?
Well, I actually did have a question for the doctor. Craig Nice is from the Burlington, Iowa Hawkeye, and also for Bill. How significant is flying now versus September or beyond in terms of keeping the support of the international partners for the space station program?
International Space Station will go for completion by 2010. That the NASA declared the Space Shuttle requirement. So to complete the mission or complete the station assembly by 2010, this September or July flight of the 114 is quite important. The delay of the mission to the right side will delay the station assembly completion. So compare this to the July flight of the 114 is quite important for us.
Do you see that starting to crumble if things don't go well here this week or within the next couple of months? At the latest?
Mr. Schraki can kind of talk for his perspective. From my perspective, the support from the international partners has been just amazing through this time frame. I often talk about a tough situation can either drive a team closer together and make them work better together as a team, or it can drive them apart. This has really driven the international partnership stronger together, and I think we all realize the vision of station. We realize the potential of what we can get out of Space Station, and we're ready to get back to assembly at the right period of time. And again, if we have to wait a couple months because there's a shuttle problem that needs to be addressed, we'll wait those couple months. We've waited as long as we've held together, and I don't see a general deterioration. I think we're ready to go fly just because the shuttle program's ready to go fly. And I think the support will stay together. The vision of station is strong. It fits into exploration. A lot of the stuff we're going to be doing on station will fit right into the exploration vision. So the fact that it's delayed a couple months in the big scheme of things won't make any difference to us.
All right, that's going to end our questions. Our next event on NASA TV is going to be the Countdown Status Briefing tomorrow morning. And thank you very much for coming this afternoon.
Good morning and welcome to the L-1 day countdown status briefing. Our briefers for today, to my left are Jeff Spalding, NASA Test Director, Scott Higginbotham, STS-114 Payload Manager.
Good morning.
And Kathy Winters, Shuttle Weather Officer. Good morning. We will begin with a statement from each participant and then we will take questions. Jeff?
Thank you. Good morning. I'm happy to be back here today to provide STS-114 launch countdown status.
on this the day prior to our planned liftoff of the Space Shuttle Discovery for its historic return to flight mission back to the International Space Station. Looking at the clock, we've just entered our T-minus 11-hour hold. That is a planned built-in hold. It'll be 12 hours and 55 minutes long. And the clock will resume counting tonight at 11 o'clock. Our launch countdown continues, and all of the work continues to go extremely well at this point. We're tracking no significant issues in our preparations as the hardware continues to perform nominally. Last night we did complete loading of our onboard reactants, which will be used to generate power on orbit. That operation was completed and the pad reopened about 11 o'clock last night. Later today we'll begin checkout of our orbiter and ground communication systems. That operation is scheduled to begin right around 1 o'clock, followed by our flight crew equipment final late stow operations. Retraction of the rotating service structure scheduled to begin about 7 o'clock tonight, followed by final pad closeouts as we continue towards anticipation of external tank load as early as 5:30 tomorrow morning. That operation takes about 3 hours to complete. Once that is done, we do send our final inspection team back out to the pad for one last look at the tank and make sure everything is evaluated and the inspections are, everything is going well with the tank itself during tanking. At that point, we do send the flight crew out to the pad. We'll continue towards strap-in and the crew module closeouts in anticipation of our liftoff in the morning, tomorrow afternoon. Our launch window, as been stated a couple of times during our briefings, is approximately 10 minutes in length. Our planned T0 open time is at 3:45, and then we do sync that time up to the actual day of launch liftoff time during our T-minus 9-minute hold, and that time, as has been reported, will be around the 3:51 time frame. We do sync up to the actual second on day of launch. 12-day mission planned, 2 weather days with no planned mission extension days. Landing still planned for the morning of July the 25th, about 11 o'clock, and 3 EVAs planned for the mission. We did get a good load on our onboard reactants, so our scrub turnaround plans haven't changed. We can still get 3 launch attempts in 4 days prior to standing down for reservicing of those onboard reactants. Again, our overall launch window in July extends from the 13th through the 31st. If we do not get off the ground during that time frame, we would need to stand down into September 9th, and that window extends through the 24th. The range is still open pretty much through the month of July, and there should be no concerns or issues with that. In summary, I'm proud to report that our vehicle's ready, the team's ready, I think our nation's ready, and with some luck our weather will be ready, so that we can begin our historic mission of returning the shuttle to flight and bringing our crew safely home. Thank you.
Good morning, everyone. It is truly wonderful to be here with you today on the eve of, as Jeff described, a very historical moment for our agency and for this nation. There's been no change in the Logistics Flight 1 hardware status since I spoke with you yesterday. We are not working any issues or concerns, and our hardware remains ready to go fly. Likewise, the International Space Station and its 2 current residents are also ready for this mission and for the deliveries that we'll be making here very soon. This has been a long journey for all of us. It's been a long story in many of our lives, but we're all committed to seeing that we have a happy ending. And with that, our hardware is ready to fly. Jessica?
Thank you. Kathy?
Well, good morning. It is a typical afternoon day in July for here in KSC, so we are expecting to see some showers and thunderstorms in the area in the afternoon. We do have that high pressure ridge that is forecast to be to the north, and what that's going to do is keep us in this easterly flow. So as the sea breeze forms, we're going to see some showers and possibly even a thunderstorm develop during the countdown. We may actually have to go red during the countdown, but then as the sea breeze progresses to the west with the easterly flow, we should actually see an improvement with the weather at the launch pad. And what our main concern is going to be is that these storms will move far enough to the west to be 20 nautical miles beyond the 20 nautical mile ring around the shuttle landing facility, which is our return to launch site concern. So we are expecting to see some weather in the area, but we should see it progress to the west. I'm going to go ahead and show you a satellite picture. We will see similar conditions today. You can see there is some clouds up to the northwest, but we will see basically a sea breeze form, and right about now, or a little bit within the next hours, when that sea breeze will form, and you'll start seeing along the coast some clouds and some showers develop. Then we'll watch it progress to the west. So let's go ahead and get into our forecast. Let's go ahead and talk about our tanking forecast in the morning. In the morning, we should just see some coastal showers. But there's a slight chance that one of those could become a thunderstorm. So we're looking at just a 5% chance of violating our tanking constraints. For our launch forecast, we did get a little bit more pessimistic on this today. We increased the number by 10%, so now we're up from 30% yesterday to 40% today. The main reason we did that is because we're expecting a little bit of westerly flow at the higher levels, a little bit of a westerly component in the upper level winds, and that may bring some of the anvils from the inland thunderstorms back into the area. So with that, we have a 40% chance of KSC weather prohibiting launch. For our solid rocket booster recovery forecast, weather still looks great for them. Nice warm water, 82 degrees, and also just 2-foot seas, so great weather for the recovery forecast. And for the CONA sites, we're looking at just good weather in general, except for just a little bit of a concern at White Sands with the chance of showers and thunderstorms within 30 nautical miles of that area. And for our cal sites, looking at a crosswind possibility at Merritt with a 16-knot crosswind there. If we do happen to delay 24 hours, we are looking basically at very similar conditions for the following 2 days. So for the 24-hour delay, we're again expecting similar weather conditions and a 40% chance of KSC weather prohibiting launch. For our CONA sites, the weather still a little bit of a concern at White Sands there with the chance for showers and thunderstorms that Space Flight Meteorology Group is expecting to occur within 20 nautical miles of the area. And then finally, if the cal sites on the 24-hour, looking for still a crosswind. That's a 17-knot component there on the crosswind, and the constraint is 15 knots. So looking for a crosswind with the winds from 270 at 12, peaks up 18 at Merritt. And finally, if we happen to go to the 48-hour time period, again, similar weather at KSC with a 40% chance of KSC weather prohibiting launch. For the CONA sites, there's a concern for showers within 20 nautical miles of Edwards Air Force Base and also Northrop. Excuse me, I stated that wrong, just for Northrop. And then finally for Merritt, again, still watching that crosswind concern in that location. So in general, weather, just definitely expecting those showers and storms in the area, watching to see how they'll progress on launch day, and hoping to get lucky and have those storms move off to the west and have a good chance for launch. That's all I have.
Thank you to our briefers. We will now take questions. Please state your name and affiliation as I call on you, and please wait for the microphone. We'll start here.
Justin Ray with spaceflightnow.com for Kathy. Can you talk about the RSS weather that you would expect this evening? Any concerns there?
No, we think the weather is going to be good for the RSS retract tonight. Any weather should be inland, so we aren't expecting weather in the location of the pad, so it should go well tonight.
All right, Mark Carruth.
Mark Carruth from the Houston Chronicle for Kathy Winter. Tomorrow, as far as the thunderstorm or shower situation, when do you sort of expect that by the clock approximately to appear, and then what's your prognosis on this moving to the west? Would it do it right as launch time approaches, or perhaps with some margin?
I think it'll form around 11 a.m. as we'll start seeing those cumulus clouds form and the showers by noon, but that will start progressing off to the west, and by 1500 it'll be pretty close to the launch time when we think those will be moving outside that 20 nautical mile ring around the shuttle landing facility.
Mark?
Just to follow on that, it sounds like what you're kind of saying is that for the mission management team and the weather people, they're going to be, from what you see now, this is going to be a pretty close call potentially, or they're going to have to really watch the trend hard during the last hours of the countdown?
I think we'll definitely be, at least on the weather side, we'll be busy. Our squadron will be very busy during the countdown, watching the weather, probably calling some constraints. If necessary, we may have to call some of our constraints red due to the cumulus clouds and then the shower activity. And then as the distance of those move away from the launch pad, that's when we'll be able to start progressing to a more green situation. And then Space Flight Meteorology Group will be the ones that will really be watching this as they are still, moving through that 20 nautical mile ring around the shuttle landing facility, and they'll make a forecast for the return to launch site forecast, and that'll probably be the main concern.
Tracy Watson.
Tracy Watson, USA Today for Mr. Spalding, I think. NASA did a big document dump yesterday, and we read about some problems most of us hadn't known about, and apparently there's some kind of radio problem with the pad, and you had a launch criteria violation, something about radio signals to the SRB, and I was wondering if you could explain that to us. It's a pretty technical document.
There was a question when we were doing some testing a couple of months ago, actually, that there may be some potential for the handheld radios that we use here on base, that there may be some interference with some of the signals that the solid rocket boosters use when the range is communicating with them. As a result of that, we went and did some analysis and testing, and what came out of that was the fact that we identified a zone where we don't want to use those particular radios during the hours when we have the range safety system powered up just prior to launch, which is approximately an hour and a half prior to launch. And that zone is inside of the launch danger area. So all of the personnel that may be inside of that area performing other duties as required, we're utilizing an alternate communication system. We have alternate radios that we're using for those folks, so they're not on any impinging or offending frequencies in that particular zone. It's a very specific problem is what it comes down to.
So what was the possible outcome of this interference, and had you guys been using handheld radios in that zone for a while?
Well, we've just implemented a new radio system within the last 2 years, and so we haven't had or been in this configuration where we would have seen this type of interference before until we started getting closer to launch countdown and started getting more into the type of testing that we would do to have those systems up. So that's why we discovered it more recently, put in place some mitigation plans on how to deal with, first of all, defining the zone of concern, and then what type of mitigation plans we needed. And again, it's a very specific concern, and it's a very small concern, and we've essentially gone a very conservative approach as far as the areas where we're going to keep radios out of that are of any concern at all to that system.
We're going to go to Todd Halverson and up here to the front, and then we'll go right to the middle.
Todd Halverson of Florida Today for Kathy Winters. I'm wondering if you are seeing any potential for cloud buildup over the shuttle landing facility and concerns for return to the launch site board with the possibility of a westward flow of anvil clouds.
Well, there is a ceiling constraint of 5,000 feet for return to launch site weather, so that would be a concern if the showers and storms were closer to the area. As they progress to the west, it may just, we think it's going to be more of the bigger concern will be the storms being within 20 nautical miles of the area. And then we may get the high cloud that comes back in, the anvil cloud. If that's coming in off a thunderstorm, that's also a concern just because that's considered a thunderstorm basically. And we don't, our constraint is no thunderstorms within 20 nautical miles of the shuttle landing facility. So there is a ceiling constraint, but I think the bigger concern will be the anvil concern.
Jay Barber.
Todd just asked my question.
All righty. Tom.
Hi, Tom Costello from NBC News. Can you talk a little bit about the spirited debate that we heard about yesterday and some of those issues that needed to be resolved, and they were going to be resolved, we understand, this morning, as it relates to the protective tile issues and also the winds at high altitudes? Where do we stand on that? Any resolution at all this morning?
Well, the discussions were ongoing this morning, and the meetings were kind of spaced out throughout the morning too, because there is some overlap of some of the individuals in some of those meetings. But I haven't gotten any results back from those meetings. We are going to meet again as a program later this afternoon, discuss the results of all of those meetings, and there will be a follow-on press conference to give you all the information that has come out of there. I have no preliminary data or discussion that's come out of any of those meetings.
Any of the issues that were brought up and were discussed in that spirited debate, could any of them theoretically be a showstopper?
Well, as always, whenever there's any issues, we evaluate them very carefully with the teams that we have in place, and whatever actions are required to do, we will go and take the appropriate actions as needed. That's why we have those people there to make those have those discussions and make those decisions. So until we come out of those meetings, we really aren't going to have anything else to offer until we find out what's going on.
Bob Hager with NBC. This is a weather question, but I think it's for Scott, really. The rationale on the 20-mile part of that constraint, what that has here, is that because of return to the abort and return to the site, or what's that about, the 20-mile?
No, okay, the answer.
It's for the return to site. That's the 20 nautical miles around the shuttle landing facility. That's for return to the launch site, to the shuttle landing facility. which is just west here, the vehicle assembly building.
As you come around and set up for the runway, that you'd have to go outside that 20-mile range.
When you come in, and I think it's when you come through. Well, you come across, they come around, and then they come around on the approach, and then come in. So I guess so.
They do a loop essentially on when they come in on the approach, and so it is a fairly large area, and they want to make sure that there's no concern with any weather within any of the portions of that flying zone that they're in.
My name is John Lamprecht from Media 24 in South Africa. I just want to get an idea, when you talk about a sea breeze, just how strong a breeze do you need?
Well, it's basically a convergence is what it is. Anytime you have convergence, and so in this case we have a southeast wind, and then you have an increase in that wind, so you get a sea breeze, which is basically a little bit of speed convergence is what we have. So when you get low-level convergence, then you get weather because you get upward lift with that low-level convergence. So in this case, you're getting speed convergence, and you still get that upward lift. And we have all the ingredients. We have the moisture in the atmosphere. We have the hot weather. And so really, what you're looking for is a trigger. And in our case, usually here in the summertime in Florida, it's the East Coast sea breeze. That's our trigger.
All right, gentleman in the back.
Hello, Ghosh, BBC News. Could I ask if the weather criteria for this occasion is tighter than normal? Specifically, that you decide not to go ahead with the launch if it's too cloudy because you couldn't get the imaging of the tiles and so forth, rather than it being unsafe?
Yes, in this case, the first couple of launches, we are going to be looking very closely at imaging, making sure that the vehicle can be seen by the ground cameras. And so the mission management team will be paying close attention to the cloud cover in the area, and I can provide information. I do provide information to them, that type of information on what type of cloud cover we have, so that they can compare that to what assets they have, what camera assets they have, and what they'll be able to see during the launch. There's not a specific launch committee criteria that has to do with cloud cover for that, for imaging purposes, but that will be a mission management team decision, and that will be one variable in that decision.
So a cloudy day would be a showstopper?
It's possible. If it's affecting the cameras directly and it's affecting enough of the cameras, it's possible that it could be a showstopper, yes.
Chris Kibler.
Chris Kibler from Florida Today for Kathy. Just wanted to know your latest thinking and concerns regarding Tropical Storm Emily.
Right. Actually, I do have a chart on that. I guess I forgot to bring that one up, but the guys back there bring it up. There it is. Okay. It's taking a northwest track on this forecast spot. This is the National Hurricane Center's forecast for Emily, and thanks for bringing this up because I meant to brief this. It is forecast to continue to move towards the northwest, and that last point there, I think that is on Sunday. I'm having trouble seeing it from here, but the track when I left the office was actually, it looked like the storm was actually taking a little bit more of a leftward motion from this track, so a little bit more of a westward motion. So right now the Hurricane Center is getting ready to issue another advisory. I wouldn't be surprised to see the advisory shift a little bit to the left. So a lot of the models are taking it south of Cuba, so more of a westward motion as opposed to coming towards us. So if that trend continues, you'll continue to see the Hurricane Center's forecast probably start being a little bit left of that last track that they have.
Kelly Young, and then we'll go up here.
Kelly Young with New Scientist for Kathy. If we don't launch until later this week or something, are you still looking at maybe Saturday for a decision on whether to roll back?
It would be the Monday-ish time period when that storm would affect us. If you took a real pessimistic track with it, the timing would be around Monday. So being in a launch configuration, normally it takes 2 days or so, but being in a launch configuration may take a little bit more than that, maybe 2.5 days or so. So it would be, once we got beyond Friday, if the storm was still coming in our direction, it would definitely be something that NASA would be talking about. We'll be talking about it all week, really, but it would certainly become more of a concern beyond Friday.
I'm a associate meteorologist in Visión Puerto Rico. I should be telling you about Emily before I get here. We haven't for Friday. However, I would like to know a little bit about the weather infrastructure here in Kennedy Space Center. How often do you do soundings, for example, to determine how quick the sea breeze will form so that can help you with the decision?
Well, we actually do soundings 3 times a day. We normally do them 2 during the winter season. During the summertime season, we do an additional one in the late morning, afternoon to get more data. When we're coming up to launch, we start launching more balloons. We've already launched one early this morning. I think we may have added an additional one right around now, or about 9 a.m. That was put on the schedule last night. So we start launching even more balloons as we get up to launch. And so by tomorrow, we'll be launching them every few hours. And some of them even get launched within every 15 minutes or so of each other.
That can help you forecast better?
Yes, we have computer models. We look at several different models. What we usually do is we try to consider the ones that handle certain situations best. We know the strengths and weaknesses of different computer models. So we do look at those. We also have regimes that we have in our training, and that tells us generally in this type of situation what type of weather we typically get, and there's all different types of regimes. So that's the kind of information that we're using to come to our forecast.
Move to the back.
Hi, I'm Javier Villasís from Univision Orlando. With all of this regarding to the weather, how is the countdown situation? Is going to change maybe tomorrow, or you're going to keep the launch for tomorrow, 3:51?
Certainly, we're going to continue on. There's nothing that we've heard thus far that would keep us from pushing on towards our planned launch and liftoff. And as always, we will evaluate the weather as we go along. And traditionally, we will, be optimistic as we always are that we'll find a hole and work our way towards that. But as always, we're gonna press on. There's nothing at this point that says we can't make it. We still have a 60% chance of success, and that's a good probability. Certainly, we've launched with less, so we're still anxious to continue.
Do you know the shuttle's agenda for today and the astronauts' agenda for today?
I don't have the astronauts' agenda in front of me. We could get some of that information today. I know they're doing a few last-minute items, but I don't know exactly what they are. As far as the shuttle goes, we're doing a lot of our configurations and pad closeouts today as we get ready to retract the rotating service structure tonight. So that's the main focus, and then our final pad closeouts through the remainder of the night as we put everything in final configuration so that we can walk away and be prepared to tank the vehicle first thing tomorrow morning.
Mark? Okay. Question in the back?
Paul Rink on BBC News. I was just wondering whether you could give us an update on the activities being performed by the astronauts at the moment, how they're bearing up, and have any issues come out of that?
There's been really no issues at all with the astronauts. Again, I think their mood is one of excitement, as is ours, and they're anxious to get back to launching. And they've been training for an awful long time, as we all know. And certainly they're prepared and ready for this mission, and I think that's their focus right now. And again, as far as an agenda goes, if we could maybe pull some things out if we needed to after this briefing, is what their plans are for the remainder of today.
All right. We have time for one more question.
Hi, I'm Tasha Steele, Discovery Channel. I just wondered what your cut-off point is for the weather tomorrow regarding the 20-mile clearance for thunderstorm. If it hasn't cleared by 3 o'clock, do you call it, or 3:30, or do you go right down to the wire at 3:51?
Generally, we'll hold at T-minus 9 minutes if we're working a weather issue and evaluate at that point. We do have at least a 40-minute hold, and as I mentioned, we do sync up, so it's usually a few minutes longer than 40 minutes. And that's our last opportunity, generally, if you will, for working weather issues at that point. And if the weather doesn't cooperate throughout the rest of our launch window at that point, then that would be the point at which we'd stop.
All right, thank you to our briefers, and this concludes the briefing for today. One programming note, the next briefing on NASA television is the NASA administrator following the mission management team meeting this afternoon. That briefing could be as early as 3 o'clock this afternoon. Thank you.
Good morning.
Oh, that's in his friend.
Good afternoon and welcome to Kennedy Space Center. Press facility as we
spend this afternoon talking with Administrator Michael Griffin. This is our question and answer session and some opportunity to talk about tomorrow's launch and also the mission. Joining me right here is our Administrator, Dr. Michael Griffin.
Hello, everybody. I just came from a very interesting mission management team meeting. The net result of all that was that we're go for launch tomorrow, pending weather. And as a matter of fact, we're not really even working any significant issues. So, in fact, I'm not aware of any issues that we're working at all. We're just working through normal closeouts and hoping that the weather gods are kind for tomorrow. I had a chance early this morning to walk down the orbiter and to meet with the crew and the crew families, and I can tell you that the crew is just raring to go, and the guys who are doing all the closeout work on the orbiter and at the pad are also raring to go. They're pumped. So we're looking forward to tomorrow, as I'm sure you are after 2.5 years down.
All right, I want to thank everybody for being out here. We know some familiar faces, some of you are not, so what I'd like to ask is that when called on to ask questions, please identify yourself and limit yourself with the amount of members that we have to one follow-up. All right, we'll go ahead and take questions first. Let's start off with Jay up front.
Mike, did they put everything they were talking about yesterday to rest today? Any other questions?
Everything is at rest today. Yesterday we were working a couple of box issues, and those are amply put to bed. We're in good shape.
Bill Harwood.
Bill Harwood, CBS News. Mike, just referring to that to close the loop on that, I mean, you're in a countdown now. There is a hurricane out there that could be affected downrange, and there's a lot of pressure to go fly. And I guess some people would say, well, you've got these issues on the eve of launch that you're going. How do you satisfy yourself that things like heating on the back box struts or the eco sensor box, where I guess you still got some suspect transistors, or at least from a lot anyway? How do you convince yourself that you don't have go fever and that what you're doing is the right thing to do?
Well, we're really, hurricanes are always out there, weather is always out there. We'll just deal with that as it comes. Our job for tomorrow, and the whole team knows this, is to figure out if it's okay to fly tomorrow. Eco-sensor issues are not so much a matter of the one on Discovery, the box on Discovery. We think that's good because that box has been put through an entire ATP cycle, acceptance test procedure cycle, and is good to go. We have had more failures on some other boxes than we are comfortable with, which does lead to the question of, questions involving aging orbiter avionics and all that sort of stuff. I was thinking during the review that I just came from as to whether or not I could find a single electronics box in my house that's 25 years old and still works, and I don't think I can. We have similar problems on the orbiter, but the box on Discovery is absolutely good to go. How do we know we're not getting go fever? Because we're working through the process. We're asking all the questions and answering them appropriately. If we can't answer them, we'll stop. It's that simple.
Marcia.
Marcia Dunn, Associated Press. This is going to be your first launch as the man in charge, and I'm wondering how crucial is it for you, for NASA, and the nation to fly a safe and successful mission?
Wow, what a question. Obviously, it is utterly crucial for NASA, for the nation, for our space program to fly a safe mission. This is my first launch in charge. You're quite right, Marcia. It's not by many my first launch in some capacity. Maybe only being in charge of a given launch, but I'm not new to this. We take it seriously. We have done everything that we know to do. I've involved myself, and the key management team has been involved in every single technical review of significance since I came on board. I have, as much as anything else, listened to the dialogue in the room. It's not about my presence there. It's about my being able to see and to work through the process and watch how others work through the process. I've listened to people asking questions and listened to answers being given. I've listened, thankfully, to arguments about whether the answer was good enough. That's the kind of dialogue we want. It's the kind of dialogue we had. If anyone in any of those engineering meetings in which I participated held something back, then I can't see why they would do it, because it was clearly a free and open environment, and I think we got everything that everybody knows about out on the table. Can there be something that we don't know about that can bite us? Yeah. This is a very tough business. It is a very tough business. But everything we know about has been covered.
Let's go to Mark over there.
Thank you, Mark Carreau from the Houston Chronicle. Either to your instruction or your expectation, what sort of vigilance is the mission management team and all the people who support them, what do you want to see in that regard during this mission?
Well, it's not per my instruction, it's per what they know to do. This mission and this return to flight is not about me or any administrator. It's about the effort that people have spent over the last 2.5 years since the loss of Columbia to figure out what went wrong, both technically and managerially, and to get it right. And I've been here the last 3 months. That's not the part that's important. Okay, it's what all the others have done. It's about them. What I would expect to see, and what I am seeing again, which in answer to Marcia's question, was the kind of free and open interchange, the kind of aggressive questioning of processes and situations and decisions that we have to get the best decisions out there on the flight line. And that's what it always comes down to. It's about the team. It's not about any individual.
I'm Deborah Zabarenko. I work for Reuters. We've seen a letter today from the Columbia families giving their support to this flight. Have you been in contact with these families, and how important is it that they endorse this mission?
Well, let me take the first part of that first. I have been in contact with several of the Columbia families who have chosen to either telephone or send me an email or converse face-to-face. I've not met all of the Columbia families. I hope to, maybe down here at this launch and maybe at other opportunities. I'm very pleased that they're supportive of our efforts. It matters. But frankly, the decisions to launch or not to launch have to be based on our engineering assessment of where we think we are. And that's what we're doing, and I think that's what the Columbia families would want.
Right back here.
Jeremy Manier, Chicago Tribune. What do you think your thoughts will be tomorrow at the moment of launch?
I'll be, along with many other people, watching displays and watching to see how it turns out. And that's all I'll be doing.
Still back on the wall, Tracy.
Tracy Watson, USA Today. To change the subject a little bit, I think your 60-day study is done right about now, and we've heard that you've made some decisions on, or that there have been some decisions reached on how to launch cargo and how to launch crew. Can you address those, please?
Not today. If you've heard that we're done with our architecture studies, that's not quite correct. We really aren't done. I haven't had the final outbriefs, and we have a lot of coordination within the administration to do before we would consider ourselves done. Today's discussions are, and my presence here and today's discussions are about returning to flight for STS Mission 114, and that's what I'm going to talk about today.
Still stay back along the wall, right there with Todd.
Todd Halverson, Florida. Today I was wondering if you saw this mission as a sort of a tribute to the Columbia crew. And I was also wondering if you considered a kickoff to the vision for space exploration.
Well, by President Bush's own words on the 14th of January last year, our vision for exploration begins with returning the shuttle to flight and completing, using it as much as possible to complete the assembly of the International Space Station. I think that every space launch we do is a tribute to all those who have gone before, the crews who have died as well as the crews who have lived. In the course of trying to conduct spaceflight activities, we in the United States have lost 3 crews. Russia has lost 2. It's a dangerous business. It will be for the foreseeable future. We work every time to make it less dangerous than the time before, every time to make it more reliable than the time before. But this is a matter to be regarded with the perspective of generations and not weeks and months. So I think every launch is a tribute to all those who have chosen to risk their lives for the benefit of this nation's progress in space exploration.
Stay along the wall with Mike.
Mike Cabbage with the Orlando Sentinel. Could you talk about what, if any, further improvements, safety improvements, modifications you'd like to have in place for STS-121 as you look down the road a little bit beyond 114? If any, are there still things that you're working on specifically that you'd like to improve on even more?
Well, we will continue to work on things such as methods for tile repair. We don't know to what extent we will eventually be able to achieve that goal. That was one of the recommendations of the Columbia Accident Investigation Board that we've as yet been unable to fulfill to the letter of the recommendation. We simply don't know how. We'd like to know how. We'll probably keep trying. After this flight, we will have, and we need to do a flight to get this information, but after this flight, we will have a much, much, much better idea of whether or not the measures we have taken to reduce debris shedding from the external tank have been effective or not effective. Now, our best engineers have put their best efforts on that, and we devoutly hope that they have been effective. But that's why they call them test flights. If we have been as good as we hope we are, then probably we will just concentrate our efforts on making sure we produce every tank as well as we produced the last one. If we see debris shedding from the tank that we don't like, that will inform future actions. And there'll be other things like of that nature. This is, again, with 113 launches under our belt, this is still an experimental test flight program. I've pointed out in other venues, maybe I can do it here today again, that in the 50s and 60s, we NASA conducted the X-15 program. It was a manned, reusable rocket plane. It eventually went as fast as Mach 6.7, just barely. We conducted 199 flights with that and had 1 loss of crew. Nobody ever thought it was anything but a test program. I think we need to adopt that attitude with the shuttle for the remaining years of its useful service. And with that perspective, I think that will inform a lot of our decisions going forward.
Right up front here, Tom.
Thank you. Tom Costello with NBC News. And to a large extent, as you know from the CAIB report, blamed a lot of the difficulties with the Columbia crash on the culture within NASA. If, as we all hope, there's a successful launch tomorrow, will the efforts to reinvent NASA have been vindicated? Will the new NASA have been vindicated by tomorrow's launch?
I don't think you can ever take the viewpoint that with a given launch or a given success that we have vindicated ourselves. There is no recovery from mistakes we've made, whether it goes back to the Apollo fire, loss of Challenger, or the loss of Columbia. Going back even further to through 100 years of aviation, the safety lessons that we who fly have learned and know are written in other people's blood. The minute we say we're good enough, we start getting bad again, and we need not to do that. So we'll be looking at our management culture, our decision-making processes, our engineering processes aggressively as long as we hope to continue to fly safely.
All right, let's move back right over there.
Ralph Artabedian, Los Angeles Times. I've talked to a lot of engineers today who say they anticipate that this will be a successful flight, that the shuttle is a safer system than it was in the past, and that as you continue to mount up successful flights in coming years, there's going to be pressure built to continue flying the shuttle beyond 2010 because they won't want to see the nation without a human spaceflight program. Is there any room in your policy to fly this beyond 2010?
There is not. I, too, want to have a continuation of human spaceflight without an interruption following the retirement of the shuttle. And I'm, with other members of my staff and with the cooperation of the Congress, am working very hard to develop a program that replaces the shuttle in good order with a successor vehicle. By the time we do that, the shuttle will have been in service for very nearly 30 years. That's enough. It's time to take what we have learned and move on. The shuttle is the most magnificent piece of transportation equipment humans have ever developed. I am in awe of the brilliant engineering which has gone into developing it, maintaining it, sustaining it. The clipper ships were the peak of the sailing art, and we don't see those anymore either except on ceremonial occasions. I think there's a lesson to be gathered from that. It's time to move on.
Let's go right up front here. Los Angeles Times. Where will you get the money to bring the CEV online? If you're moving it up from 2014 to 2010, then you don't have a budget gap that will maybe allow you to save some money for this. I know these studies are underway now, but I mean, can you talk about that?
Nope. You must not have listened to my earlier answer.
Jeff Patterson with WFLA-TV. I'm wondering, you talked about the question of tile repair, and if there were ever a problem and the orbiter were damaged on ascent, can you see a situation in which you would put a shuttle crew at risk with a patchwork job done in space, or would you just bring up another shuttle to bring them back home?
Well, we will have shuttle rescue capability for the first couple of return-to-flight flights, for the first couple of flights in the return-to-flight sequence. And then after that, if we intend to complete the International Space Station, we cannot take an orbiter out of the flow indefinitely to have a rescue capability. So we will have to, at some point in the not-distant future, make a decision that our engineering improvements regarding debris shedding by the stack are either good enough to fly or are not yet good enough to fly, and we'll have to keep working on it. So we'll make that decision when that time comes. But we will not, for the long term, be able to maintain a rescue orbiter capability and still build the station.
All right, let's go back over here towards the back. Good. There you go.
Hello. Sri Stockton with the Palm Beach Post. I wanted to ask a follow-up actually on your statement earlier about the X-15 and experimental versus operational. How can you treat the shuttle as an experimental vehicle if you intend to use it over the next 5 years for 20 operational flights to build a space station? Is there an inherent conflict in that?
I don't see one. The fact of the matter is that we consider operational equipment is very different in nature and kind from the Space Shuttle. Space Shuttle is one of 3 remaining orbiters. Each is slightly different from the others. Each has to be carefully prepared before each launch in a unique way. There's really no resemblance between what we do to process any space vehicle for launch and what we do to process even the highest tech military aircraft for launch. I think when we call the Space Shuttle an operational system versus an experimental system, we delude ourselves on that, and I don't propose to do it.
Right there next to you.
Stephen Kass, IEEE Spectrum. Moving again, we know there are some physical things outstanding. We would like to have better tile repair. We would like to have better on-orbit repair. Coming back to Earth, in terms of the management structure, looking at the management structure, the evolving thing, what kind of changes would you like to see going forward that haven't already occurred for this mission in the MMT and other places?
Well, I think I answered that question earlier, or I tried to. Maybe I didn't succeed very well. I think the mission management team, as it is constructed today and as I have observed it, is working just fine. Okay, I think we want to preserve that going forward, make sure we don't lose that. What we want from a mission management team on an experimental program or a program involving an experimental vehicle like the shuttle is an attitude of constant willingness to question and to halt the progress toward flight until our questions are answered as best we can do. With something that is right at the edge of the state-of-the-art, like human spaceflight, we can never know that we have all the answers. All we can do is the best that we can do, and that is enabled by getting the best minds we have available and making sure that they have an opportunity to speak. Part of what the CABE report alluded to in shuttle program management and decision-making leading up to Columbia was an environment in which people felt unwilling or unable to speak up, to raise doubts, to raise concerns. And that if those doubts and concerns had been raised and listened to, that it would logically have followed that the program would have stood down. So the key then to breaking that accident chain is to having an environment in which people can make their concerns known. I believe we have that today. And so looking forward, what I want to do is to preserve and extend it.
Let's go with Warren right up here.
Warren Leary, New York Times. You mentioned that at the end of the countdown you'll be in launch control watching the monitors and that. Traditionally there is a countdown where the launch chief polls loud stations and everyone says go, go, go. In this case you'll be there. Are you going to be the last guy polled, and will you say go, and it's essentially all on you?
I don't expect to be polled, and I don't expect to need to say go or no go. I believe that the launch team is entirely capable of exercising those functions on their own. I will be there to see what goes on.
Stay on this side, right? Third row.
Randy Avera, Randolph Publishing. On that same line of thought, after the Challenger accident for return to flight STS-26, there was an NSTS office based out of Washington led by astronaut Bob Crippen involved with the go for launch. Who is the actual person for the STS-114 return to flight who will give that go to launch, and how does the Director of Engineering, Director of Quality, and Director of Safety feed into that ultimate decision?
Well, the ultimate go for launch, I believe, is provided by the Associate Administrator for Space Ops, Bill Reedy. But in the launch polling that takes place, that was referred to by Warren's question, there are opportunities for safety and mission assurance to say go or no go. There are many different positions in the overall line of command that can vote up or down.
Stay on this side.
Alan from Univision, Puerto Rico. Millions of people will be watching tomorrow. As media people here, what do you think will be the most important message that you would like to be perceived by the public? What would be that?
That we have come through a very difficult period at NASA in our progress toward developing human spaceflight, and that we're back online and ready to go.
A few more questions. Let's go right back there. Stay back.
Curtis Kruger, St. Petersburg Times. Is it realistic to think you can get all the remaining space shuttle missions done by 2010, or might you have to scale back the number of missions?
We will, by definition, get all of the remaining space shuttle missions done by 2010, because the number of space shuttle missions that will be done will be those that fit in by the end of fiscal year 2010. That is the President's directive, and that is how this agency will execute its program. The question is, how many shuttle flights can be accomplished, and what work on the International Space Station will have to be deferred to the new system, or what can be accomplished with the shuttle.
All right, let's stay right back there.
A.J. Hostetler with the Richmond Times-Dispatch. Back in April, several crew members said they did not want to fly a repaired shuttle back to Earth. How will the crew's thoughts play into a decision on whether to attempt to repair or whether to have the crew go to stay on the space station until rescue from Atlantis?
Well, STS-114 Discovery doesn't have any substantive repair capability. We have a couple of experiments on board, and indeed, it would be a very interesting question as to whether, if we sustain some damage that we thought was repairable with the experimental methods that we have, it would be a very interesting question as to whether we would want to try that. I would regard that as pretty much a last-ditch attempt, with the more logical early moves being to, as you say, house them on board the station and launch at Atlantis in the event of, again, a mishap of that nature. We could, I suppose, get to the point where we would want to try a towel repair as being the best alternative, but I'm not prepared to comment on that right now. That's way farther than we've really thought.
Let's move towards the back row, very back. Gentlemen, there you go. Oh, very, very back.
Greg Dobbs with HDNet Television, Mr. Griffin. You have pointed out that this is a test flight, but at the same time it ought to be, by rights, the safest shuttle flight in history with all the innovations. So how do you characterize it?
If I didn't believe that it was safe to fly, or as safe as we could make the shuttle to fly, I certainly would withhold launch approval. I do think that this team has done everything it can do. I've spent a good portion of my time on the last 3 months trying to assess exactly that issue. Again, I think they've done a magnificent job. They've come through the most difficult period in the history of American spaceflight to get to this point, and I think they deserve our appreciation and congratulations. That's, I guess, really all I know how to say about that.
All right.
I don't know. I'm sorry. I don't know how to answer that question because I don't know how to measure the quantity you're seeking to measure. You're asking, is it the safest? As someone well trained in statistics, I could immediately start talking about how even 113 shuttle flights is not a large enough database to allow us to answer in a meaningful way the question that you're asking. What I've said, several times today, and probably will find reason to say again, is we've done everything that we know to do. There is nothing that we know of that we have not addressed. Are there things out there that we don't know about? There may be. We sure hope not.
All right, just a few more questions before we wrap up. Let's go right back in.
Dragging that microphone around, sorry.
I'm Tom Boyle from the Tipton, Iowa Conservative. In future manned spacecraft, would you stack them like Apollo Saturn, or would they be clustered like Shuttle?
I don't know. Maybe some of both.
Right here in the middle.
And also to you yourself, what's the launch tomorrow, or yourself along with your people. But how about other high-ranking officials of the government, including Mr. Bush? How do they observe the tomorrow's launch?
I'm sorry, I can't understand what you're saying.
Oh yes. How do the other high-ranking officials, including Mr. Bush, would observe the launch tomorrow?
President Bush has a cabinet meeting in Washington tomorrow, and so I'm sure they will be watching it on television.
All right. Let's get some folks that haven't had a chance to ask a question right over there, right in front there.
Hi, my name is Takami Hanza from Kyoto News. You describe the whole shuttle mission as a dangerous business, and I understand it's tough. So what was your toughest decision and the time since the time you took in charge?
I have not had any difficult decisions to make since I've been in charge of NASA.
I'm not touching that one. All right. You guys had a question there? Oh, here we go on this side. Let's go right there.
For the TV Tokyo, what has been the total cost for return flight, especially factoring in the new safety measures?
I don't have a figure for that for you right now. I simply don't know. I can quote back the same media estimates that I've read from you guys, so I don't want to do that. I don't know. I, again, have come in at the tail end of this, and my job, as I've seen it, has been to assess whether our return-to-flight activities have been successful. I believe that they have. When I have some breathing room, I'll sit with others and take a look at the history of how well we did all that, how much money we spent, and so forth. But I just don't have that right now.
Okay. Right up here.
It's a bit of a Japanese domestic question. Could you give us a few words on what you think about having Japanese astronaut Mr. Noguchi on board, especially on this much anticipated flight?
Well, I think it's great. Anytime we have any of our international partners flying on the shuttle or flying with us to the station, as we expect in the future. Soichi is not our first Japanese astronaut, and I expect that he won't be our last. I spoke with him this morning. He's quite excited. But once one of our international partners joins a crew, or joins, for that matter, an engineering team or a development team, they become part of the NASA team, and they are treated like everyone else, and we soon stop noticing where they come from.
All right, right up here.
Randy Avera, Randolph Publishing. As we get back flying again safely, could you give the world a comment, some of your feelings about your excitement as a rocket engineer for going back to the moon?
Well, I think it's less a matter of feelings than of logical necessity. I believe that it is important for America to be the preeminent spacefaring nation in the 21st century and beyond. Spacefaring nations go where they can go, and the solar system is laid out such that beyond low Earth orbit there is the Moon, there are the near-Earth asteroids, there is Mars, and then there are places beyond that that will remain for future generations. So I think the proper purpose of the United States civil space program is to explore, develop, understand, discover the solar system, and extend the range of places where human beings live and work. That's what we're here to do. We're at the very beginning of that right now. The technology is primitive compared to what we would like it to be and need it to be. The expense is great. The risk is very significant. But we will never be where we want to be if we don't take these first steps.
All right, well, that's going to conclude today's press briefing with the administrator. I want to give one note to pass along. The launch time, new launch time, is now for Eastern time tomorrow, 3:50 and 53 seconds. And wanted to pass that along as the new launch time. All right, thank you for joining us, and we look forward to tomorrow. Thank you.